and here we go.
There's the deluge. Here's ignition.
Doubling up.
Did he just do a kerbal?
Back to the moon and beyond.
Put that in the big bag, you know.
Back at home, we all have a lot of work to do, but from here, it sure looks like a perfect flow.
Propulsion continues to be normal.
We did have an observation.
Equalization.
343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center.
Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my god.
Yikes. You bet. Sure. We don't need any more of these.
Hello everybody, we are live once again from the Kennedy Space Center in Florida because this rocket, the Space Launch System for Artemis II, is going back to the VAB. Not exactly the news we wanted to hear the other day, but there has been a little bit of a problem which needs rectifying with the access platforms only available in the vehicle assembly building. But we want to do this properly. We don't want to rush these things. We've seen what happens in the past when that has gone, when things have been rushed with rocket launches. Not great conclusions. So best to do this properly, which is why NASA is currently rolling SLS back to the barn. My name is Ryan Caton. Thank you very much for joining us this morning. As it looks like NASA is running about 43 minutes behind their original first motion time, which they posted the other day, but nonetheless, they've got plenty of time to get this vehicle back to the vehicle assembly building. Could take anywhere from 8 hours, could be 10 hours, could be 12 hours. We truly don't know. It just depends what NASA finds on the next 4 miles. Alongside me, it's not just my voice, because we have also got the other Ryan from NSF. Ryan Weber is joining us this morning. How you doing, Ryan?
I'm doing pretty good. Yeah. Here to watch SLS roll back. It's as you say, it's a little disappointing it's rolling back, but of course we want everything done right, especially on a crewed mission. And let's hope NASA can get this sorted out and fixed quickly, and we can get to launch the Artemis II.
And in the field, we have Jerry operating the cameras, and of course, Max Evans joining us. How you doing, Max?
Good morning, everybody. Yes, not to beat the dead horse here or sound like a broken record compared to y'all, but yeah, a bit unfortunate to see SLS rolling back, but it is better. They are better off doing this right than trying to rush it and create more problems. So, yeah, a bit sad to see it coming back, but also it's more opportunities for content. So I'm never going to say no to that with a big orange moon rocket.
Indeed, and fingers crossed you're able to get some up close photos? Question mark. Wink,
yeah,
wink.
I will. Yeah, I will only be on comms for the next maybe 15, 20 minutes because myself and Jerry are actually heading inside of the vehicle assembly building to maybe set up some cameras to catch it coming in when it comes in. Maybe wink, wink, nudge, nudge. And we will be picking those up hopefully tomorrow morning if all goes well. So yes, very exciting stuff happening today. But I should be back on with y'all later in the evening once it gets closer to High Bay 3.
Wonderful, and it might look like the rocket isn't moving at times. I will just clarify, this thing does move incredibly slowly, so it is crawling away. It's just difficult to see, but I can confirm over the last 5 minutes the rocket has moved. You might need to scroll forward and back through the stream a few times to actually see it moving, but I can promise you it definitely is moving. Anyways, there is, should we say, some interesting reasons, Ryan, why this rocket is having to roll back to the VAB. If you wouldn't mind just giving us a little bit of an explainer of why the rocket is coming home, considering they already faced some problems with the hydrogen, and now they're facing some problems with a different element. The next element, should I say.
Yeah, literally like the next element on the table. They are having issues flowing helium to the ICPS. Could be a valve issue, definitely could be a tank issue. But the issue that they are encountering cannot be fixed out on the pad due to access issues. This isn't like Apollo, where they have this massive structure that can roll up next to the rocket and enclose the entire thing and have work platforms to work on the whole thing. They don't have one of those for the Artemis program. So they have to roll it back into the vehicle assembly building, put the work platforms around the ICPS, open it up, fix whatever the issue is. They can pressure check it in there, and then they'll roll it back out when they're ready to go. Now, for this kind of a fix, it shouldn't, in theory, take too long. However, I don't expect SLS to roll right back out. They have that clock on the FTS. It's like 21 days, if I remember correctly, on the FTS batteries, which they have to reset and update based off the Eastern Range, because SLS uses a manual system, and it's a different system compared to most other rockets. Now, in order to do that and still make their April launch windows, I think it would be like around March 12th is when they would probably roll back out at the earliest. If not, they can probably figure out how to roll out a little bit later, and they'll still be able to be within that FTS timeline and be able to, get the rocket back out, hook everything back up, do whatever testing they might want to do with it, whether it's like a little pressure test probably with the helium systems, and then maybe even another confidence check on the tail surface mast umbilicals, because of course you're rolling it back to the vehicle assembly building, you're rolling it back out. So who knows what that does to the seals, of course. So we'll wait and find out.
Yeah. There are a few questions about that already coming into the queue, and if you are joining us for the first time, a little bit of housekeeping. If you have any questions or comments, make sure to tag us in chat at NASASpaceflight or at NSF, and those will come into the question queue, and we can then do our best at answering those on stream. So I'm sure we will be talking about that in the not too distant future. But in the meantime, we have gotten a little bit of support before the stream even started. First of all, Hugh Rightly, thank you for becoming a Red Team member. We also had DL Vaughn, 1963. Sorry if I pronounced that incorrectly, but thank you for becoming a Launch Director member. That's the second highest tier of membership on YouTube. Flippers79 McGregor, part of our team, gifting 5 Red Team memberships. Thank you for those. Of course, if you received one of those, make sure to thank them in chat. And Shazbert Toddbot, what is up, Space Nerds and the Nerd Kings of the NSF crew? Thank you for your $10 super chat, and yes, welcome to the stream. Fingers crossed. There's some exciting things to be playing because, of course, or watching rather, because, of course, as Max alluded to, there is going to be continuous coverage on this stream of this rollback. We are going live right now with commentary for the beginning of this roll. We'll then take a little bit of a pause as SLS makes its way down the crawlerway, and then when it gets closer to the VAB, we will come back on commentary to talk you through the final moments of the rollback, probably for an hour or so before the rocket makes it back into High Bay 3, because there's some interesting things that happen with the vehicle as it goes through that specific part of the journey. But one of the most exciting parts coming up, Max, is the roll down the hill, because, of course, with the high water table in Florida, these launch pads, 39A and 39B, were built on a big concrete mound. So we have a question here from Sean Leonard asking, does the platform that SLS is on level itself while it goes up and down the hill?
So the actual platform itself does not level itself. It's the crawler itself, or CT2 or crawler transporter 2, that actually has the ability to level itself coming up and down the mound. So it has a series of hydraulics and also actuators, of course, to help make sure that the platform stays at a perfectly level angle, to make sure that SLS is not leaning in any particular direction and putting stress on any other parts of the vehicle or the mobile launcher itself. So the platform itself, again, the platform itself does not level itself. It is the crawler that does, which is really cool. But it has been doing that since Apollo, and that's just how old the hardware is here, actually. The crawlers were designed and built in the mid-'60s, before the Saturn V was flying at all. And of course, they are still both technically usable today, although CT2, or Crawler Transporter 2, is the only one certified for the Artemis program, with Mobile Launcher 1 and hopefully 2, and the SLS Block 1 and hopefully Block 1B launch vehicles. So Yeah, very, very unique pieces of kit there, but they are very, very old.
Still really impressive machinery nonetheless. And you can see there on the left-hand side a replay from the rollout of SLS of that leveling actually taking place with the crawler there, which is really cool. We have another question here from a leopard's tail. There we go, a leopard's tail. Is it still, or does the crawler driver have to wear a seatbelt for safety? I don't think so, if I remember correctly.
I don't know.
They do only go like 2 miles an hour maximum. So I'd imagine it's probably...
It's actually even slower than that, Ryan. So when the mobile launcher and the rocket are on top of the crawler, I believe the top speed I believe is 0.75 or 0.8 miles an hour. Like that's about as fast as it can go with the vehicle on top. But without any payload on it, I believe the crawler can go about 1.5 miles an hour, maybe 2 miles an hour if they're really pushing it. But yeah, it's not. I mean, for a vehicle its size, that is pretty fast. But it is also the heaviest self-powered vehicle in the world, as it's certified by the Guinness Book of World Records. So, but again, in the grand scheme of things, not the most blistering of pace.
Let's have a look through here. Johan is asking, do they need another wet dress rehearsal or tanking test? Ryan, I don't think NASA has said anything official to that degree, but what do you think? Do you think they're going to be doing another tanking test when they return to the launch pad, or do you think they're just going to get right ahead into those launch campaigns?
I think depending on when they roll it back out, like say if they roll it out with a decent amount of time left before they want to hit their April launch window, I would not be surprised if they do like a 25% confidence test to check the seals. And of course, check the flow of helium, check out all the other components and everything. I don't think they'll do a full. They already did that once, and that did pass with flying colors. And of course, they ran into another issue. But I honestly think that they would just do a small confidence check more than anything, especially if they have the time to do it. I personally would want them to do it. It's being cautious, especially with a crewed launch here.
I wouldn't be surprised if we see any sort of propellant flowing through the TSMUs, tail service mast umbilicals, just to see. Might be a good idea to see if those seals remain have integrity after rolling 8 miles. But again, for Artemis 1, they replaced the seals, rolled back and forth to the VAB, then launched perfectly fine. They had a maximum of a 6% leak rate of the hydrogen from the TSMU. So there is precedent for this being okay. So we will just have to wait and see what NASA decides to do. Fingers crossed there is some sort of a press conference or something that we can ask them about this as well in the coming days. But as you can see, the vehicle well and truly making its way down the hill here ever so slightly. Still coming up on the bigger or more steeper part of the hill, but it is very much departed the main location on 39B, where the vehicle has been sat down for over a month at this point almost, which is quite a long time. Almost feels like this thing rolled out yesterday.
It kind of does, which is kind of scary.
And you can see it if you squint at like a specific part of the vehicle and you just stare at it for a few seconds, you can see it moving ever so slightly. It's very difficult, especially with the heat haze. The heat haze does kind of make you imagine what you're seeing a little bit, but you can see, especially if you kind of look at the water tower in comparison to the right SRB there, you can see it moving forwards ever so slowly.
I don't know if we have the ability to like super zoom into the crawler tracks, Carson. I know he loves it whenever we actually produce. But you should be able to see some movement between the actual ML itself and also the crawler tracks being spun around. I'm not entirely sure, but once the vehicle gets closer to the VAB here later on in the evening, our cameras here will 100% pick that up nice and easily. So yeah, kind of. Like mostly on the right-hand side of the crawler, you can see some spaces appear in between the actual tracks themselves as they rotate down the hill. But it is kind of hard to see, but obviously it is moving.
Yeah, the heat haze really not helping. Sorry, Ryan, I interrupted you.
It was basically the same thing you said, just a lot of distortion. Yeah.
Yeah. We have another question from O Hydrogen, interesting username. They are asking, how do they access the interim cryogenic propulsion stage in the VAB? Well, Ryan, they have many, many access platforms, right? So could you talk us through how they're going to be actually fixing the ICPS, so to speak, in the VAB? If it's even a problem with the ICPS, because like you said, it could be a ground filter or something.
So they have work platforms that can basically extend and cover multiple levels across the entire rocket. It's preformed to the core stage plus the SRBs as well. It's the vehicle assembly building has had these work platforms installed with them since they built the thing. They've switched them out per rocket. So, of course, you had them with Saturn V, you've had them with Saturn 1, you've also had them with, S shuttle, and then, of course, with SLS. So they basically will roll it in, they'll set it down, they'll roll the crawler out, and then they'll extend all these platforms so they can access all different levels of the rocket. And they'll have to do the FTS reset, as we were talking about earlier. They'll be able to open the access hatches and get access to the ICPS, and do any other work that they might want to do on it. Because while it's back in the hangar, you might as well look at other things that maybe if you ran into little issues here and there, if you got the time to do it, you might as well work on it. So they'll definitely take a good look at the rocket while they have it back in the bay. And then once they're done with it, they'll retract the platforms and they can roll it back out.
And it's basically impossible to see from this view, unfortunately, because of the distance. But as the vehicle gets closer, they'll become more apparent. But the ICPS, or sorry, not the ICPS, but the LVSA, which is the Launch Vehicle Stage Adapter, and that is that conical orange shape which connects the core stage to the upper stage. So it's basically the pointy bit at the top of the core stage. That has some access hatches in it, which can be opened up, and that allows teams to get inside and actually access there we go. Thanks for the zoom in, Carson. They allow crews to actually get inside of that adapter and access the ICPS, because of course it is shrouded by that in this stacked configuration. And if they didn't have those access hatches, NASA would have to destack the vehicle, which might not seem like a big deal for Starship, but for SLS that is a huge deal, which is why those access hatches, exist.
Yeah, let's hope. I don't know if they have ever said what the issue is. I don't think they've said exactly what it is, but the hope is that they can get through the access hatches and then work on it that way, and they can fix it that way. Let's hope it isn't anything more serious, which it shouldn't be based off what they've kind of said. The hope is that they just can quickly fix it and get it out again. So.
And with that, Max Evans has got to go because there's some pictures which need, or rather some cameras that need setting up. So we will see you later, Max, and have fun.
Thank you, everybody. Sorry to be departing so soon into the stream, but there are some very cool things that need to be done with Jerry and I. So, but of course, we will be back later on in the stream as it gets closer to the VAB. So we will see you guys later.
We have another question here from Liz Marshall. We did talk about this a little bit at the top of the stream, but we can talk about it a bit more. They are asking, do we have any idea of how long the work will take? And that's a great question, because the short answer is no. I've always been guessing maybe minimum of a week, because, NASA, in the kindest way possible, NASA takes its time. I think minimum of a week, could be even longer, and I've been saying that for a few. I think I even said it in the Breaking Space video at the weekend. So, Ryan, what do you think? How long do you think this work could take?
If it's just a simple valve replacement, I would say up to a week to extend the platforms, open up the ICPS, swap out the valve, or, well, they have to really get in there to really double check what the issue is. My guess is they'll get in, they'll probably do some actuation of the valves, maybe a small pressure test to watch some stuff, and then they'll narrow it down to the actual fault if they haven't already narrowed it down. There's a possibility they've already done that. If it's just a valve, quickly replace the valve, do a ops check of it, and close it back up and get it out. That could only take a week, but as someone who has taken off panels on vehicles, you never know what you can find. I know this is a newly stacked rocket. It is definitely, it's not like it's old or anything like that. But whenever you take a panel off of something, you can always find more stuff. So the hope is that it's just this one issue and then close it back up and get it out. But I know all too well what it is to find other problems just when you're trying to fix one other thing.
Let's have a look through here. Again, if you are just joining us, I know more people are going to be with us at this point than at the start of the stream. So if you have any questions, make sure to tag us in chat at NASASpaceflight or at NSF, and brings all your questions and comments into our question queue, and then we can do our best at providing some useful answers, I think is the best way to say it. Let's have a look through here. Oh Hydrogen again with the questions, asking, could the SEALs move again with the 8-mile journey back and forth, and also blame everything at this point? Good point there. I'm sure we'll be talking about that in a second. But as we were talking about, they replaced the SEALs on Artemis 1, and then they had to roll Artemis 1 to the VAB and then back out to the pad, and it launched fine. The leaks were well within margin for that specific launch, and this time around, the hydrogen leak margin has been extended up to 16%. On Artemis 1, the leakage was 6% at maximum. So that's a great question. I'm sure we would love to ask NASA, but my gut is that they'll probably be all right from this point. Ryan, what do you think?
I think it'll be fine. If they didn't really have the issue in Artemis 1, the hope is that they won't have any issues on Artemis 2 here. Hopefully they should be able to just roll it back, do whatever they need to do, roll it back out, and have no issues with any seals, and just do maybe either a confidence check, or maybe they don't do one and they just do the quick helium check out at the pad and then get ready to launch it. We'll see.
We will see indeed. And the vehicle is getting closer to the steeper part of the ramp here, so we will soon start to see the crawler do its party trick, leveling out, keeping the vehicle vertical while it is at an incline angle, which is always awesome to see. So do keep an eye out for that as it starts to roll down the hill here. It has been moving for about 25 minutes or so at this point. First motion, according to NASA, officially 9:38 this morning, Florida. So there you go. Nice to have an official update from NASA. Johan is asking, how long does the retraction of the work platforms take? Are we talking hours or days? I'm pretty sure it's hours. I'm trying to recall back to before the rollout, the initial rollout for Artemis 2. I'm pretty sure they retracted the work platforms the day before rolling out, or maybe even the afternoon or evening before. Ryan, I'm pretty sure it doesn't take that long at all, because these platforms are designed to extend and retract, right? They're built into the high bay.
Yeah, it shouldn't take that long to retract and extend those. I don't know what motors they use. It could be electric to extend those out. I'd have to look at the inside the bay again to see how they're moved around, but they shouldn't take too long to extend and retract.
Johan also says, I'm happy as long as we can avoid blaming good old Engine 3. Engine 3, of course, caught a little bit of slack on Artemis 1 for a problem which didn't actually end up being Engine 3's fault, which was quite funny. Lee Sweet is asking, are they going to replace the batteries as well, as long as they're in the vehicle assembly building? If you are unaware, I believe the batteries in question here are for the flight termination system, which of course has its own independent power source, different from the main power source of the rocket, because if the rocket breaks, you want to make sure your flight termination system can still work. That's a great question, Ryan. I don't know if you want to talk about that again, because even though they now have the brand new contingency access platforms to update the flight termination system at the pad, I mean, when they're in the VAB, they can. Surely it'll be even easier to access.
Yeah, they'll replace the batteries and reset the FTS system. We were talking about that a little bit earlier. Once they do that, they'll have again that 21-day clock from the Eastern Range, or I'm trying to, maybe it was extended. I have to look back to what the exact days are. But talking to Alex in our back channel, basically, in order to have the comfortable room and around the April launch window, it'd be rolling back out around March 12th or so at the earliest. So they'll definitely reset the FTS system in the VAB, and then they'll roll it back out.
Fingers crossed, not too long from now. Let's have a look through here for some more questions. Bol Eskov, so if I pronounced that incorrectly, they're asking, did they have this many issues with the Saturn family of rockets and gaseous seals? Obviously, the shuttle issues are better documented. I am not confident on any specific problems that the Saturn family had, but I do know for a fact the Saturn family had problems, because not only was this a brand new launch vehicle, it was the first time a launch vehicle of that scale had ever been built, and Saturn, of course, used a variety of different propellants throughout its stages, and they definitely faced delays, they definitely faced problems, but I feel like the Apollo program sometimes is looked back on with rose-tinted glasses, and kind of a bit more nostalgia than realism for the problems it did face, and simply at times how dangerous it was. Ryan, I don't know if you know of any specific examples on any problems that Saturn faced.
Apollo 11 is a pretty big one. They had an LH2 valve, I think it was the S4B upper stage. They had an issue with it. They had to go and fix a leak on the primary, I think, supply LH2 valve on that. I know shuttle had problems. We'll just go with that. I don't remember all of them off the top of my head. I'm not the person to ask that, obviously. That is more of a like Sawyer or Crispy question on that one. But hydrogen has always had its issues, and other gaseous seals. I mean, heck, even SpaceX still has issues with gaseous seals, even with like methane. You can still have seal problems, and stuff like that. So whenever you're dealing with cryogenics and high pressure gas, seals are always can be a problem. Heck, even on jet engines, when you're doing, like pre-cooler control valve seals and stuff on engines and whatnot. It's definitely always an issue. Seals are one of those things that they're amazing when they work, and when they don't work, they're a pain, because then you got to fix it. So it doesn't matter what rocket or vehicle you're dealing with. Heck, gasket seals on internal combustion engines, once they stop working, it's not great anymore when you blow a gasket seal. So it's kind of works a bunch of different ways.
Indeed. Okay, let's have a look through here. We have a question from Space Enthusiast H2 and HE Blamer. And they are asking how many tons of fuel is used in Artemis 2, how many tons is used at liftoff. Well, I can tell you for the core stage, there is 987 tons of propellant spread across 144 tons of hydrogen and 840 tons of oxygen, which is a lot of tonnage, and I mean is a great example of just how not dense hydrogen is, because it accounts for, what is that, like 20% of the mass of propellant, yet accounts for like 80% of the core stage height, which is pretty crazy considering, you know, just how dense it is compared to the density of oxygen. The ICPS, on the other hand, I'm not 100% sure. I'm going to see if anyone is able to figure that one out. But 13% in mass, Alex is telling me, for the hydrogen on the core stage there, which is pretty cool. I'm doing some rough, you know, never do maths on stream, but doing some rough calculations. I'm pretty sure the ICPS has just shy of 29 tons of propellant on board, if I am not mistaken. And
sorry.
Oh, go on, Ryan.
I would say most of the fuel for SLS is in its, at least the fuel weight is in its solid rocket boosters. And most of the weight, a good chunk of the weight of the rocket itself is in its solid rocket boosters, with the, because you have solid fuel plus the steel casings. It's not like Starship or a lot of other rockets where most of the weight is in the propellant itself. A lot of it is, or in liquid propellant, I should say. A lot of the weight of SLS is in solid propellant.
And of course, that propellant can't be offloaded. It's of course loaded when the SRBs are cast. So the crawler is carrying that weight as well as the weight of the rocket when it is rolling to and from a launch pad, which is pretty cool that it's able to lift that much mass. Because remember, those SRBs is literally the size of a Falcon 9 booster. So that is a Falcon. Imagine 2 Falcon 9 boosters full of solid propellant being rolled back and forth from the vehicle assembly building. Oh, and there's also a core stage and the upper stage and the Orion capsule on top. Pretty heavy. Oh, and there's also the entire launch tower, by the way, also being moved at the same time. Pretty heavy. Pretty heavy.
You know, it's funny, and I know people have asked this question in the past on whether or not SPMTs could move this whole thing, and the answer is yes. You have enough SPMTs, enough axles, you could do it. In fact, the axles set up for the launch mount move for the Starship launch mount, you could do about that many axles, add a couple more on them, so kind of you'd probably do like 338 axle ones because you want margin. And then you also asked the question, oh, can it go up the grade? Yes, it can. SPMTs are good on a like 12% grade, and the grade up the pad is like a 5%. So SPMTs could move this whole stack. The problem is you'd need some kind of cribbing between the SPMTs and the actual pad itself in order to get it high enough to set it on the stanchions that the launch pad basically sits on when it actually gets to the pad. But SPMTs could totally move this thing. It's just the crawler way's not really set up for that.
Really?
But yeah, it can't do it on the rock. You put enough axles on it, and you can spread out the weight with a modified stuff. You should probably be able to move this thing. Yeah.
It would need to be much bigger than the crawler, though, right? Because you'd need to have many more axles.
Wider surface area than the crawler, absolutely, because you'd have a decent amount more axles. Yeah, to spread out the weight, because basically the crawler is able to take all that weight in one area. So with SPMTs, you'd have to have enough axles to spread out the weight, and then you'd need a structure in order to spread out the weight along the SPMTs itself. Pure weight-wise, you could probably do it, but you'd have to come up with a contraption to actually spread the weight out enough to do it.
Okay. Similar question here from Zine, they're asking, why does the crawlerway need to be sprayed with water? It's quite difficult to see here, but there is a white truck just ahead of the crawler as it crawls down the ramp there. Ryan, why do they spray the crawlerway with water? I think you can even see where the crawlerway has just been sprayed with the little dark patches on the rocks.
They spray it to try to keep dust down and everything when those large tracks are going over rock and of course the concrete and everything like that. It helps protect it. In fact, there you go. They're starting to spray it down now.
Good timing.
Yeah, it's good timing there. So now they're looks like they're getting to the ramp, so they'll take their time getting down the ramp as the crawler transporter adjusts for the grade change on the ramp. And then it'll go and hit the crawlerway, and then it'll level out as the crawler transporter is basically half on the ramp, half on the crawlerway. It'll start to level itself out, and then of course it'll get leveled out, go on the crawlerway, and then quote unquote they can speed up, if you know what I mean. I don't know how sped up it is, but they go a little bit slower going down the ramp because of course it's going down a ramp, and then they can go at their 0.75 and take a nice trip back to the vehicle assembly building.
Of course, this trip back to the vehicle assembly building brought to you by helium, because not only are we blaming hydrogen, but we are also blaming helium. Yes, the NSF store team has done it again. We brought you the Blame Hydrogen shirts design following the initial wet dress rehearsal issues back in the end of January, beginning of February. But now we have another SLS delay because of helium. Yep, element number 2 has been a little bit pesky, just like element number 1. And it's another element that we have to blame. But not only do we have blame helium, I know a lot of you were not blaming for the helium and that you voted for methane, which is another design that we also have in the shop. Don't blame me, I voted for methane. So if you want to compete against the elements you are supporting with the delays of SLS, those are now available at shop.nasaspaceflight.com, which is very, very funny indeed. The store team once again knocking it out of the park with these rapid response elements to blame designs. Blame hydrogen first, now the blame helium, and of course don't blame me, I voted for methane, which is awesome indeed. More molecules, there you go, more molecules now available at shop.nasaspaceflight.com. So if you want to support or I guess it's not really support in the case of the helium one, I don't know, if you want to support your favorite element there, shop.nasaspaceflight.com. Available for your purchasing pleasure. It always amazes me what our store team can do there. We have another question here from AC Gypsy, and they're asking, best guess who launches first? SLS, Starship version 3, or New Glenn Flight 3? Ryan, what do you think?
Of all of them, New Glenn Flight 3 goes first. Artemis II goes second, and Starship Flight 12 goes third.
That's actually quite surprising because I actually agree with that. I think there's a good chance that we get a New Glenn flight next month, then the Artemis II flight at the beginning of April, and then Starship whenever Elon time happens. You know, we don't actually know the offset, but I don't think it's in 2 weeks' time. Sorry, Elon.
No, the Starship has a lot of things left to do before they can even launch. We're thinking, I know this is Artemis, so this Starship is related. We're thinking for Flight 12, Chip 39 will likely be out hopefully tonight is the possibility. There's a production of Massey's closure. So 39 might roll out for cryo and some other testing. So there's that. Booster still has to finish getting its engines and roll out for a static fire. And they still have a bunch of other testing, plus wet dress rehearsals and everything like that. And all of it's a new pad, new vehicles. So there's a lot of things they got to do there. SLS, they just need to roll it back, do a quick fix on the ICPS, reset the FTS. Hopefully don't find any other issues, roll it back out and go. Assuming they don't find any other problems, which, I mean, it is SLS, but I'm going to cross my fingers, say they don't find any other problems, and it goes in April. And then, of course, New Glenn, I don't know about New Glenn 4, but I'm pretty confident New Glenn Flight 3 will go in March, but we'll see.
That website on your screen, very useful, nextspaceflight.com, also available on the Play Store and iOS App Store if you want to keep up to date with all the upcoming and previous launches and Starship activity and different reusable rockets as well. We have a nice little database in there which you can take a scroll through, so very useful tool. If you don't already have it downloaded or bookmarked, I would highly recommend you do, because well, it's what we all use to keep up to date with all the different launches, so it's probably what you should use as well. And there you go, you can see Artemis II no earlier than April 1st. Not next month, nearly next month. Just over a month from now. We're 5 days away from March, so almost next month. And it looks like we already have somebody in the store getting the brand new Blame Helium design. Tyler saying, love the content, keep up the good work. But not only has Tyler got the Blame Helium design, they've also got the Don't Blame Me, I Voted for Methane design. I'm not quite sure how both of those are applicable, but nonetheless, hopefully you enjoy the new designs, which are available right now at shop.nasaspaceflight.com. Oh, and it looks like Greg has also been getting the Blame Helium, this time on the mug.
But yeah, I always love our store team when they come up with funny merch like that. It's always funny.
We have another question here from Gina G, and they're asking, what exactly is meant by extending the hydrogen percentages, and what are the implications of this, both good and bad? I'm pretty sure essentially the leak rate is measured as a percentage, and the allowable leak rate is being raised for Artemis 2 compared to Artemis 1, because Ryan, of course, hydrogen is always going to leak. There is no universe in which humans can manufacture a seal where hydrogen will not leak, so some leakage has to be expected and accounted for. So they're just kind of, I assume they've done more analysis and they're raising that percentage based on data they've collected, right?
Yeah, I will say this for seals as a whole. If your seal, a funny saying is, if your seal isn't leaking, that means, or say if your seal is leaking, that's when you know there's fluid in there. If your seal isn't leaking, then there might be an issue because it might be dry, kind of thing. It's kind of a funny joke as mechanics, but yeah, when you increase that hydrogen percentage or extend it, you're basically saying, okay, we've looked at the data, we've looked at the hydrogen concentration in the area, and you're saying that, okay, there isn't an issue if there's this much hydrogen around there. The vehicle's fine, the loading is fine, and we're not going to run into any problems, whether it's with, I guess, explosive issues, or, you're not going to have enough hydrogen left over in order to fuel it, or there's not going to be, danger to the pad or to the, the rocket or the people on board or anything like that. So that's where a lot of that analysis comes from. It helps them give more of a margin. And it's kind of what you do a lot of times when you're making a new vehicle. You always want to, when you're doing tests, you have to analyze your leak rates. You have to analyze all your sensor data. And when you start off, you always start very strict when it comes to a lot of data points. Usually you go, okay, well, the thrust setting here, pressure setting here. Well, we've seen how the vehicle interacts with the pad while it flies, all this other stuff. How can we adjust it to where we can give ourselves more margin for error as we move on? Basically, I know SpaceX has probably done that a ton of times with Falcon 9, how they're able to get it so efficient and everything like that. They don't have as, many issues running into leaks because they know their limits. They know what the limit is of the rocket. They know what the limit is of the GSE systems. NASA's still learning because this is only the second mission of Artemis. So they're still learning how this rocket works. It is what it is. They're still learning. They haven't done a ton of, I've only done one flight. So you learn, you test, and you adjust your systems.
This lightning tower eclipse is almost perfectly lined up to make it look like there's a huge lightning rod slapped on top of the Mobile Launcher 2 tower right now, which is pretty funny. Almost looks like the 39A fixed service structure on wheels. And DLS016 is asking, after replacing the seals at the pad, didn't those numbers go to sub 1%? And that is true, except for, I believe, when they pressurized the core stage. So the maximum leak rate that NASA saw on Wet Dress Rehearsal 2 for the hydrogen was 1.6%, I believe, during the pressurization of the core stage. So, but again, the majority of the count, the vast majority of the count, that leak rate was sub 1%. So good progress after replacing those seals on the hydrogen TSMU. And we can see now the space launch system and the mobile launcher and the crawler well and truly on their way down the hill at this point, and the crawler doing a great job of keeping the vehicle level while being able to move down that gradient itself, which is always really cool to see. And I think, I don't know if it's my eyes playing tricks on me, but it looks like they might be spraying some more water as well.
Probably are as they continue to go. Just put more water down.
Yep. Of course, they can't go too far ahead because this is Florida, and that water will evaporate if they get too far ahead. So always got to be a little bit close to the vehicle, close to the crawler as they make their way back to the VAB. This new design looks very popular. Gregory is saying, so long as it isn't the Illudium Q36 explosive space modulator, we should be good. That sounds like a sci-fi reference I don't understand whatsoever. Ryan, can you help me? Do you have any idea?
It sounds familiar, but I don't remember off the top of my head. I have to pull it out of my brain. Stand by.
Okay. Well, at least it's not my fault that I don't know what that is. Forgive me. Anonymous has been in the store and gotten, looks like, one of everything. Getting the SLS assembly shirt. Also getting, let's see what else they got. The Blame Helium mug, of course. The Don't Blame Me t-shirt. And the Blame Helium t-shirt as well. So hopefully you enjoy them and they arrive pretty soon. Jack has been in the store. Round 2 of trying to secure an assembly shirt. I blamed pairing it with the hydrogen shirt the first time, so I might be tempting fate again. Looks like there you go, getting the assembly shirt and the Blame Helium shirt. And Wilbo in chat, thank you very much for your support as always, Wilbo. Always great to see you in chat. Thank you for your ongoing support. As always, it is greatly appreciated.
It's from Marvin the Martian cartoon, by the way.
Okay.
Yep.
I still don't know what that is, but I thank you for the context. We have a question here from video, or rather a suggestion from video game developer, and they are saying, should they just increase radial symmetry to the maximum on the SRBs and flight light the RS-25s? I mean, I'm sure that would add a lot of thrust to weight ratio. I'm not sure if it would be too comfortable for the crew on board at the top of this rocket. Maybe that thrust to weight ratio would be a little bit too extreme. I'm not even sure if there is a structure strong enough to handle the thrust of 8 5-segment shuttle-derived SRBs there, because they are huge.
would be what is that? It's from a Scott Manley video way back. He looked at some ugly and weird rockets, and it was like a shuttle slash like Saturn launch vehicle or something like that. It had I think like 8 SRBs on it and like 2 S1C stages or something strapped to it. It was this abomination of I don't even know what to call it, but that kind of reminds me of. I don't really know if you could design the core stage to handle that much. You'd have to overbuild it like crazy, and at that point, what is the point of the core stage? Like what? It's like just make that your first stage. 8 SRBs. Oh, so Ares 8X, right? That what it is?
Yeah.
Oh God, no, that's They're Alex have actually a Jupiter 3. Okay, that's right. It was 2 external tanks attached to I think a S1C or like a Nova, and then it had like 4 SRBs or something like that. Yeah.
That's like apparently if Ares 1X is silly rocket, this is super silly rocket because that is ridiculous. 2 external tanks, 4 SRBs, Saturn first stage, and a partridge in a pear tree. That's ridiculous. Okay, Jacob has been in the store, also getting the Blame Helium t-shirt. These are very popular. Well done, store team. One thing I should just mention quickly, I have been reminded, just like the Blame Hydrogen, the Blame Helium is a limited time only. So if you want it, get it while you can. They're not going to be in the store forever. Just a word of warning on that one. Jacob also got the... Oh, this is a classic. The Texas Tank Watchers Snapback Trucker Hat. There you go. Apparently trucker hats are a big thing. So if that is what you want, if that's something you are interested in, shop.nasaspaceflight.com is the place to be.
I think, I mean, if we're going to come up with ideas for modifying SLS, I say you do 4 SRBs with 5 or 6 RS-68s instead. If we're going to keep hydrogen, use RS-68s instead. I know you have to modify them for human rated, but it's a higher thrust engine. And also we don't have that way we don't throw away awesome shuttle engines. And then that rocket would probably be able to put like 100 tons in the LEO. Oh, and then of course instead of the EUS, you use the Earth departure stage with J2Xs. Boom. There you go. Kind of like an Ares 5, but with 2 more SRBs.
Yeah, I was about to say you're literally just describing Ares 5 there. You could have truncated that sentence into Ares 5. But yeah, the RS-68 is a very cool engine used across the Delta IV, especially when it kind of lit itself on fire. I wish SLS would do that. I understand safety implications and whatnot, but it's just cool, It's just cool.
Can you imagine a Koryolev cross with 4 SRBs?
Oh, that would be spectacular.
That would be insane.
That'd be beautiful. Especially as they're still burning out, because of course the SRBs don't cut off immediately. They still kind of sputter out at separation. Especially at night, and it'd be like fireworks. That'd actually be like incredibly pretty. I'm doing that in Kerbal after this stream.
Oh, you're doing it in Kerbal? Okay.
Let's see here. This is a great question from Sard. Is it true, in the case of a toilet malfunction during the elliptical orbit, they will cancel the translunar injection and come back? I think so. I think there is a mission plan or a mission rule where if the crew can't be comfortable, as in be able to do their business, they are not allowed to proceed with the mission and they have to come home. I think that is a mission rule. I think.
I'd have to look.
Yeah, I mean, it's a very awkward mission rule if that is the case. I can already imagine the headlines, but it is a much more comfortable experience inside of Orion than it was inside of the Apollo crew capsule, considering that those specific circumstances, and I think we can leave that there. Steve says, if the toilet is broken, then if you can't go, then you can't go. I mean, that is true. The store is popping off. Christopher has been on the store. Thank you very much. Getting the don't blame me, I voted methane. Love the content. Thank you, NSF. Well, thank you for your support there. Ricardo has gotten the assembly instruction shirt and the Flight 11 patch, which again, all the patches are kind of one batch orders. So once we run out of the patches, they are gone forever. So if you want a patch, make sure you order one now. Annette has been getting the Blame Helium. Clever design from hydrogen to helium. Had to get it for my son. Well, thank you very much, Annette. Thank you for your support. Getting the... oh, we got a sticker sheet as well. I didn't even know we had a sticker sheet. We've got a Blame Helium sticker sheet. Look at that. That's awesome.
You could use Blame Helium not just for SLS, but for Starship too. Way back in the day.
Yep. A very versatile design.
Yeah.
You can even go beyond rockets.
Indeed.
And, oh my goodness, Chris Bray with a $50 tip at tips.nasaspaceflight.com. That is a direct way to support us that bypasses all of the other platforms, and that goes straight to NSF. And Chris says, thanks for all the coverage. If someone can reach out to Jack, ask how's the bacon coming. I'm sure Jack is making or cooking plenty of bacon in his new role at he joined in November rather. His new role at Astroforge, but yes, I'm sure Jack is very much enjoying the bacon back in California. But thank you, Chris, so much for that support. It is greatly appreciated, and I can assure you that is going directly back into the equipment and making it all happen. And there you go, all of the Blame Helium things. We've got the sticker sheet and the mug. Oh, it also got a hoodie as well. Awesome. I believe this is pinned in chat right now. So if you want to get some helium, if you want to Blame Helium, it's linked in chat. But seriously, Chris, thank you so much. Support like that goes a really long way into helping us keep doing what we're doing. Because, of course, we are independent. We are not owned by a huge media conglomerate. We do not have, millions and billions and trillions to waste on things. We genuinely try and stretch every dollar we get as far as it'll go. So thank you so much for that support. It is truly greatly appreciated. We have another question here from C. Ferguson asking, how long will SLS be in the VAB and when is it to enter the VAB? Well, in terms of the rollback timing, I think it's safe to say probably 8 hours from now is the soonest it's going to be back. These rolls can take anywhere from 8 hours to maybe 12 hours. It's only 4 miles, but they go really, really slowly. They take these things really, really carefully. Of course, they don't want to damage the vehicle in any way, shape, or form. So taking their time, as NASA would expect. In terms of how long it's going to be in the VAB for, I think it's going to be a minimum of a week, maybe even longer. Brian, what are your thoughts on that one? Or how long do you think it's going to be in the VAB for?
Considering the timelines we've been talking about over the last little while, I think it'll be down. I don't think it'll be in there for like 2 weeks. They'll time it to roll it back out with the FTS reset like 2 weeks from now, March 12th or later. So the fix may only take like a week, but there's no reason to instantly roll it back out again if you're then going to just have to do the FTS reset again at the pad. So you might as well just keep it in a vehicle assembly building, do it in there at the last moment, and then roll it out and get it ready for launch. So probably like 2 weeks.
Yeah. all depends on what the issue is as well. Fingers crossed it's a small issue that's quick to fix. And I just realised they have flashing lights on the mobile launcher. I suppose they... Well, it's not... I thought that was only needed for permanent structures. This is a mobile structure. Or maybe it's just height.
It's for structures of a certain height, you're required to have strobes. I think we all know very well the nice bright white strobing lights on Pad 1's tower over at Starbase. Yeah, if it's an FAA rule, is what it is. So that has it.
Is it like rotating or something? Because they keep, unless someone's just playing with the switch, they keep turning on and turning off again, and they're back.
Those are strobes. But it feels like some of them are really going a lot and some of them aren't. It is kind of weird.
Yeah.
Maybe someone's having some fun just flipping a switch, flipping a couple of switches. I don't know.
Yeah, they don't seem like they seem to flash like 3 times and then they don't flash for a minute. Anyways, getting distracted by strobe lights here. Similar question from that one WestJet Aviator. They're asking, how long do the vehicle assembly building doors take to open? Will it take hours, days, or minutes? Well, Ryan, I'm pretty sure those doors are kind of like panels. I don't think it takes too long. I'm sure if it's anything, it'll be a few hours, if not shorter.
If I remember correctly, it takes like 45 minutes for them to open the door. Because there's separate panels, and they can pretty much open them. They kind of open them sequentially as it kind of goes up, if I remember correctly, and it takes like 45 minutes or something along those lines. I have to look at the exact time again, but it doesn't take that long to open those doors.
And we have another question from Sard asking, did NASA not expect this much time spent after rollout before launch, considering that the HLS loiter requirement is 90 days and on Artemis 1 they couldn't access the FTS on the pad? This is a great question, considering the Human Landing System loiter period. I would think for Artemis 3 they would launch the lander after the crew, or like when they have at least when they have a very good idea that the crew is going to be launching soon. What do you think, Ryan? Because that is 90 days is a long time.
Yeah, it's going to be interesting timing-wise because SLS rolls out, my guess is they would roll out SLS, and then after it rolls out, assuming and with the hope of not having any issues lined up for Artemis 3, so say the rocket is good to go, and you're like 2 weeks away from launch, like basically you've done your wet dress, you've done your checkouts, you've done all that, everything's good to go, you then launch HLS. So you launch, well, for Artemis 3, you would be HLS Starship. You launch it likely from 39A. And then that has to dock with a depot, at least 2 depots to refuel, along with a bunch of other fueling flights, which should be already made before that. And then that goes on, does its full TLI burn and goes to the moon, which will take at least a few days to get there. So within that point, once you get there, you then start that 90-day clock. So say you're 2 weeks away from a launch from Artemis, and say HLS gets there a week into that moment or something along those lines. If SLS has to roll back to the VAB for any issues, it still gives them a decent margin to roll back out and launch. But that's kind of where I think they would do the timings at, is after a wet dress and after everything is sorted and they're relatively confident they won't find any other problems, that's when they launch HLS. Because then if they do find an issue for some reason, they're already far enough along in their checkouts that they just got to do one last thing. If they have to roll it back out and launch it, and they're still within that 90-day window. It'll be a fun timing thing to watch, see how they do it.
We have got more questions in here, so we will go through those as quick as we can. We have Owen, who's asking, what is the time frame for the VAB maintenance and a launch window? We've just been talking about that maintenance period in the VAB, but Ryan, of course, there is some launch windows coming up. Unfortunately, those March launch windows, which are the next ones, NASA has ruled them out at this point because of this rollback. But when is the earliest that SLS could launch, and what kind of windows has NASA got to play with?
So there's April 1st, and then there's the second. No, there's the 3rd, 4th, 5th, and 6th. I have to look up exactly what the windows are, but if I remember correctly, none of those are during the day. I think they're all sunset or later, or like really, really early in the morning. I have to go pull up all the windows off here. But basically, it's like first week of April is their next opportunities. And that's why, like, if they were to roll out around March 12th, that gives them a solid 3 weeks to play with, to, roll it out, do some final checks. If they have to do a 25% confidence check to make sure the seals are good, make sure their helium loading is good. And then, of course, the crew will, once they're confident, the crew then enters their 2-week quarantine, which would start on March 18th. So roll it out on the 12th. Hopefully you get that confidence check done maybe the 16th or 17th. And then if everything's good to go, crew enters quarantine and you try for April 1st. So that's kind of what we're looking at, assuming it's only in there for like 2 weeks or so. But of course, if they have to push it a little bit later, they will. After that first week of April, it isn't until April 30th that they have another opportunity. So that would require an FTS reset at the pad. But they can do that with Artemis II and up because they have work platforms that allow them to do that FTS reset at the pad. So that's their opportunities coming up. Hopefully they'll hit April 1st or maybe one of those day, either the 3rd, 4th, 5th, or 6th. It'd be really nice to see this thing go. I want a nice smooth mission. It's a crewed mission. First humans around the moon in a while. And I can't wait for them to roll it back out and get going.
Indeed. Almost looks like they're at the base of the ramp here. As SLS makes its way back to the VAB. I don't know where this has come from, but we keep getting questions surrounding Blue Moon launching on SLS. Blue Moon is not going to be launching on SLS. Blue Moon is Blue Origin's lunar lander and is going to be launching on New Glenn. So Hyman is asking if they'll be on different pads. They are going to be on different pads because SLS can only launch from 39B, and as it stands, New Glenn can only launch from Launch Complex 36. So they'll definitely be on different launch pads. But yeah, again, Blue Moon is not launching on SLS. I'm not quite sure where that misconception started, but Blue Moon is going to be launching on New Glenn. Either the 7x2 or the 9x4, I guess, depending on what type of New Glenn is in operation at that point. We have another question. Oh, go on, Ryan.
Let's say it's 11. Yeah, the separate pads are 11.8 miles apart or 19 kilometers, give or take, in a straight line. So, yeah, they're a little bit far apart, but I still want to see a shot of SLS on the pad with New Glenn on 36, like one of those really wide out shots. And then, of course, before Artemis 3, I want to see SLS on the pad with Starship HLS on the pad literally next door at 39A. That'll be really cool. I hope we see that.
And, of course, even though 39B and 36 are like 3 numbers apart in numbers, again, 12 miles apart, not next door. Plenty of distance between them. We have a question here from Chris, and they are asking, speaking of other rockets, could Orion be integrated with another platform or booster? Theoretically, yes, because, again, Orion is built by Lockheed Martin. Lockheed Martin is even technically looking for commercial customers for Orion, not just NASA. So, theoretically, could we see Orion launching on a Vulcan or a New Glenn? What do you think, Ryan?
Well, it would work well on New Glenn. I don't know if Blue Origin would buy it and do an adapter for it, because they have the tower. They would just need to build a crew access arm that works with Orion, and then of course you'd have to make sure New Glenn is crew rated. But I don't think it would be that hard to do. But of course, that also means you need to more or less design freeze New Glenn to do that, and they're definitely trying to figure out and update New Glenn as they go at this point. So I don't know if they would do that. Vulcan, it wouldn't really get it to the moon. You get it to low Earth orbit, but the other problem is you have to launch it with its service module and everything like that. So there are definitely options you could try to figure out. I know this question's been asked a ton of times. What other rocket you could put Orion on? I think it stays with SLS. I don't know if it goes on any other rocket once it's done once SLS is done. But I mean, we'll see.
I agree with the New Glenn point there. And again, that would take a little bit of time because New Glenn has flown twice so far, and just like SpaceX did with Falcon and what has been done with many other launch vehicles throughout history, the more data you get, the more you're going to be able to optimize that launch vehicle, and the more you're going to be more confident in it. So, and the more you'll be able to upgrade it as well. I'm pretty confident there'll be upgrades coming to New Glenn even before the new 9x4 9-engine variant, which is going to be coming up in a few years' time, according to Blue Origin. And Bender D is asking, will they do another wet dress rehearsal before launch? That's a great question. I was going to say hopefully not. I guess it kind of depends what side of the fence you sit on. I think, personally, even a minimal tanking test might be wise to see, just, what's the correct way to say this? Iron out any potential issues that might arise during the rollback and the roll to the pad. What do you think, Ryan? Do you think they should do a full wet dress? Do you think they should do a tanking test, or do you think they should just get right into launching?
I think a 25% confidence test wouldn't be a bad thing to do. It would test the seals. It would test tanking. Make sure all the connections are good. And I think it would be a good test, kind of like a small tanking test, like if you were like at Starship were to do, not loading the whole thing, just loading the tanks up slightly, and just testing connections, make sure everything's good to go. SpaceX has done that many times, and I don't think it would hurt to do that for SLS when it rolls back out.
Yeah, I have to agree. Anonymous has been on the store getting the "Don't Blame Me, I voted methane" t-shirt. Put the top on super heavy and go. I think that might be a little bit overkill, but nonetheless. Lee has been on the shop and has been getting the Blame Helium mug, saying, I love the coverage. I've watched every launch from Alan Shepard until now. That is pretty cool. Thank you so much for tuning in. Fingers crossed Artemis II does launch not too long from now. Bideford in chat supporting us once again. Bideford is always in chat. Thank you so much. Bideford doing my job for me, telling everyone to click like and help with the algorithm. I do agree with that statement there, Bideford. Thank you very much for your support, your ongoing support. And Micah has been on the store getting the SLS assembly shirt. That's what I'm trying to say. Saying that NSF actually sparked their interest into rockets in space. So I will forever blame you guys. So thank you for your support. Okay, with that, we have a long roll ahead of us. So we will not be talking, unfortunately. Sorry to disappoint. For the next 7.5, 8, maybe 12 hours. So in our place, we will have the Space Tunes returning. DJ Carson is going to be playing some music for you all. Anyways, we will be returning with commentary as SLS gets closer to the VAB. So, in the meantime, Ryan Webber, thank you so much for joining us on the first part of today's stream.
Pleasure as always, and hopefully we see this thing get back, within the next Should be within the next day, as we said, within the next 8 to 12 hours. And hopefully, whatever issue they got isn't too big. They can fix it quickly, get it back out onto the pad, and we can see Artemis II go around the moon.
Of course, thank you to Max and Jerry, who were out in the field at the beginning of the stream and then had to go and do some fun, cool things, which I'm sure we will get even more. We'll get some cool pictures, more cool pictures coming up over the next 24 hours or so. And of course, thank you to Carson for producing this part of the stream. And yeah, the stream isn't going anywhere, so don't go anywhere. We will continue to stream the rollback, but as I said, it's a long process, so we're not going to be talking for the entire time, because I'm not sure that would be a great idea even if we attempted it. But thank you so much for tuning in to our commentary for the first part of today's stream, and we will be back talking to you in a few hours' time.
Comms are live.
Welcome back, everybody. Yes, the music has disappeared. You see the progress bar. A little over 80% of the way there now after rolling from Launch Complex 39B just before 10 a.m. this morning Eastern Time, heading back towards that vehicle assembly building to roll back, get some repairs done, and then hopefully head back out to Launch Complex 39B sooner than later for the Artemis II launch. I am Sawyer Rosenstein. I will be your host for the remainder of this rollout broadcast. I see the 5x5 emojis. That is one of the few things that is working in YouTube chat right now. We are aware that YouTube chat is kind of gone bonkies, shall we say, and not working anymore. So we have other ways that you'll be able to ask us questions. I'll go over that in a second. And by us, I mean, of course, I'm not alone. Joining me on commentary as well is the one and only Philip Sloss. Philip, how's it going?
Good. Hey, everybody. Apparently, YouTube is speak no evil right now.
And speak no good and no speak no anything other than emoji. Yeah. And then also out in the field, we have Jerry Pike, who's operating some cameras, as well as Max Evans operating some cameras in addition to our robot army out there. Let me just tell you, we have some spectacular views coming up in the remainder of this broadcast once we roll out and get some special camera vantage points. And you can see right now that roll along the crawlerway at the whopping high speeds of a little under a mile an hour, or approximately a mile an hour at this point. And I should also point out that Jay Keegan is the one who's pushing the buttons, pulling the levers, and is also the one who had been maintaining the tunes up to this point. Now, chat is kind of randomly working sometimes and not, but have no fear, we have other ways that you will be able to ask us questions in the meantime. So we also are live on Facebook, so the Facebook chat will still be available to answer questions, and we will have a post shortly up on our X account, and once that post goes up, you'll be able to reply to it with questions there, and good chance also to check out all of our socials while we're there. While you are there. So go ahead and try that if regular YouTube chat isn't working. When YouTube chat does work, though, the at NASASpaceflight or at NSF should be your go-to. So at this point, Philip, from what we've been watching, everything has seemed to be going relatively smooth. We've had a couple of stops, but nothing crazy.
Yeah, and it seems I guess this is in the opposite direction. Seems a little bit like the rollout, where they seem to do the second half of the rollout in short order, not like really flooring it necessarily, but they have seemed to be making steady progress since they made the turn at the crawlerway split.
Yeah, and again, they start off extra slow, of course, going down the hill and around the curves, but at this point, it's mostly a straightaway from here on out. There's still little curvature, and there's kind of this little, almost like C-turn that they have to do right before they get into the VAB. But for the most part, at this point, it's a relatively straight shot down the crawlerway, which is nice. And a reminder, kind of for people that might just be getting caught up or might forget, of course, we have the rollback here now. We're hoping, after two beautiful, successful wet dress rehearsal tests in WDR2, or I should say terminal count tests in WDR2, everything was looking great. And then, we had issues after that.
I think we had there was that 12-hour period of time where everything was great, and then we woke up on Saturday and not so much.
Yeah, that was a shock and very sad, especially because we were on the flame trench the day before going, oh, this is amazing. We're like one flame trench away from then being able to launch this thing to the moon. And about that. Here we are.
Yeah. Yeah, and I think that's going to be that will be interesting to see how that factors into what they're going to do when they get back out to the pad, because they did achieve several of the test objectives that they basically had that they'd had to defer from Artemis 1. and including those 2 terminal countdown runs, and also the ability to recycle in between them and get both of those in within 2 hours time, because that's your typical maximum launch window. And so when they get back out to the pad, even if they want to mitigate the possibility of another hydrogen leak and do a tanking test, maybe they don't need to do the full wet dress rehearsal where you take the vehicle all the way down inside of 30 seconds before ignition. Maybe you just do the LH2 integrity test that they did a couple of weeks back.
And then, of course, finding ways to be able to test the helium lines on the ICPS as well, because those are also used for purging out the engine up there, as well as pressurizing the tanks to flight levels, right? So is that something that they could also test during a, I guess, tanking test and then simulated terminal count, or?
Yeah, I think that's one of the questions is what if they decide to do a tanking test, what's the content for it? I think I believe that they also use, this is part of their pneumatic system for the ICPS main propulsion system, and so I believe that they also use it. The valves are pneumatically actuated. Some of the core stage valves are also pneumatically actuated, and so they are using it for that in addition to the tank pressurization and purging on the in-space SLS second stage.
So I guess the other question then is this something that they can test inside of the VAB, or is this something that they'll have to then bring it back out to see if their integrity works? Because obviously they can, they can pressurize and purge the lines, as we saw with ground systems, because the main issue seemed to be the onboard flight systems, not the ground side.
Right, and apparently this issue, the vehicle had been completely inerted after the second wet dress rehearsal. This was, I don't know if you'd call it ambient conditions, but I think that's a good question. And of course, the ICPS with its Delta heritage has additional flight history. Perhaps the main propulsion system is close to identical to the old Delta cryogenic second stage. And as you said, if we're just talking about helium, it is possible for them to do a validation test either in the VAB or at the pad without having to go into a full cold flow.
I mean, that would be nice. And one of the other concerns I've seen, though, is people saying, well, yeah, because everything was fine with the seals and whatnot, and then they fixed it out there. Maybe it could have been jostling from the rollout and from all the vibrations and things as they're going from the VAB out to the pad. Is there any concern, especially with them fixing the leak seals on that hydrogen side and going, yes, we've got this, we've tested it, we've validated it, we're good to go? Is there any chance or worry at least, that there might be some jostling and loosening on the ride back into the VAB and then again back out to 39B?
I mean, I think it's an open question. I mean, I know they did the press conference right after the second wet dress rehearsal on, what would that be, Friday, and that was one of the questions I wanted to ask John Honeycutt, who is now the mission management team chair for Artemis II, but who used to be the SLS program manager and was for several years. One of the things I wanted to ask him was, without knowing we were going to run into this helium issue and rollback, was when the next time they roll an SLS vehicle out to the pad, will they consider disconnecting the hydrogen tail service mast umbilical plates and reconnecting them to mitigate whatever issues there might be from loads rolling out to the pad? And not necessarily knowing that they were going to have to do this again with the Artemis II vehicle. So I think we're going to find out here much more quickly than maybe 2 or 3 years from now whether they're going to use this workaround again.
Unfortunately, yeah, I think we're definitely going to be finding out sooner than later. Yeah. And
Yep.
I think it's safe to say that once they go back out to the pad after this, they are going to have to do some kind of tanking test and validate that the seals are still holding. Because, I mean, the numbers that they were giving us, the fact that, the first wet dress rehearsal of Artemis II, we saw leak rates of over 16%. I believe it was up to 18% inside the tail service mast umbilical, which is that kind of shape that you see there on that right side of the screen, that sort of V-type stuff there. Those are some of the tail service mast umbilicals. And to go from 16% to the largest that they saw of 1.4% is just mind-boggling to me, how they were able to get that fixed and sealed and resolved, and now they run the risk of ruining it again. It worries me, I'll say that.
Yeah, I mean, I think you were asking, I would say, again, from just an armchair quarterback perspective, I think there is some level of concern from the outside looking in that if they were to just leave this alone and go straight into a tanking test without doing anything, I think that would be kind of a head scratcher. But again, we don't know. And just again, for orientation purposes, the liquid hydrogen tail service mast in this view is on the right. So left hand is the liquid oxygen tail service mast umbilical, and because hydrogen likes to find places to escape a lot more easily than other molecules. It's possible that there are other locations on the vehicle, other umbilical plates that actually see higher loads from the rollout. It's just this one is especially sensitive because you're running liquid hydrogen through a line that has this quick disconnect, and they have two lines that have this quick disconnect. And so, I think it's a question right now, and I'm kind of hoping that we get a little bit of an outlook from them talking about what they're planning on doing when they go back out to the pad. And I think even before then they gave us a little bit of a hint about the other things that they're going to do in the VAB. They only mentioned a couple of other things, is to talk about, are they going to do anything to the tail service mast umbilical in the VAB, or would they just basically wait, go out to the pad, and then readdress it when they get back out to the pad to, basically reestablish the umbilicals after it's hard down on the pedestals out of the pad again?
It's a lot of questions right now, and I know in the original post regarding all of this, Jared Isaacman, NASA administrator, had said that they will do a more in-depth briefing later in the week. We are already at midweek at this point, so we'll have to see if they end up doing something Thursday or Friday, or if it ends up being something next week. But I do hope that they give us a chance to have another press conference and to ask more questions about this specifically, because there are a lot of question marks that we're just talking about here, and that's only part of the the concerns going into the rest of the Artemis II campaign and testing, and also when they think they might be able to actually get this thing off the ground. Because I know for a long time, I believe this goes back to when Bill Nelson was NASA administrator, the goal was always no later than April of 2026. And with this likely taking all of the March window off the table, do we think there is still a chance that they can get this off the ground during the early April window? Because that would be April, 1st, 3rd, 4th, 5th, and 6th, I believe.
Yeah, those are the dates that they've talked about, and I think that is the question, sort of the high order question here about work in the VAB, work when they get back out to the pad, is do they have enough time to get the vehicle ready to launch by April 1st, which is, I believe, 5 weeks from today. So let's see what the time is. What is that? I mean, we're at almost literally 5 weeks from right now, give or take an hour or so, is when the launch window would open. And so no fools. And so that's the thing, is how much time are they going to need in the VAB? And then the more time that they have at the pad, in theory, you would have more time to do tanking tests and to address the issue with the hydrogen. Again, it seems like there is unknown or it's a known unknown now about there being some level of risk to rolling this vehicle out. And of course, we don't even know what the connection, if there really is a linkage between the rollout loads. That's just what they talked about. But we've now seen 2 vehicles roll out to the pad and have issues after rollout with hydrogen leaks in this particular spot, in this particular umbilical. And so would they just, would they tank this vehicle even partially without addressing that? I think that's the question. And if they wanted to do that as an experiment, I could see it being an interesting experiment. But then the bigger question is do you have time to do that experiment, or would you rather spend the time, just go ahead, redo the umbilical connection, and then do a tanking test? Or if you wanted to do the scientific method and see if you could implicate the rollout loads more or less, you would do a test first without doing anything and then see what you get. And of course, if let's say you get a different result, that would be kind of odd too.
Yeah, and I mean, even from this view, it looks like you can see those vibrations on the vehicle.
Right. Yeah, that's interesting. You can see the very tip of the launch abort system tower swaying there, and the vehicle and the mobile launcher has a vehicle stabilizer, which is there to brace the vehicle to some extent for lateral loads like this, not just from rolling, but also from wind. And of course, this is a very tall vehicle, and so I don't know if we have any wind, like a windsock or something up there at the top of the umbilical tower, but I would imagine that they're seeing some of that regardless of just because it's up at altitude. And so but that's what the vehicle stabilizer is there for, is to stabilize the vehicle against lateral loads like that. But it also does put loads on these umbilical connections, which have to stay connected right up until the booster ignition signal, and then they have to very quickly disconnect. And so there are plenty of other hydrogen connections throughout this vehicle. It's just in the other cases they are almost permanent connections, like bolted flanges, and I think that's probably the primary type of permanent connection are bolted flanges, where you've got bolts probably at maybe 20 or 30 degree intervals around the entire circumference of a line. In this case, it's a as the name implies, it's a quick disconnect connection.
Yeah, years ago I had the privilege of actually going into the yard where they were doing the quick disconnect testing for this launch tower, and the amount of connections, as you were pointing out, the different bolts and things that are in place there to secure it, there's a good amount of them, but to be able to then have to swing back, retract, and then in many cases have a protective cover clamp on top of them in a matter of seconds, it's amazing the engineering that goes into those type of things. It's mind-boggling. Also mind-boggling is the fact that you can literally see the shadow kind of rocking back and forth there on the launch abort system tower up at the top. And you made a good point there also. We see this kind of like structural things sometimes along the vehicle, but most of that is just stabilization. When it comes to holding the mass of the entire vehicle in place and basically keeping it so it doesn't really fall over, the majority of that is just the weight of the rocket itself, right? It's kind of holding the base, and those two SRBs are taking a lot of the, brunt of holding things up.
Yeah, and so the weight of the vehicle is holding it down. So now again, this is one of those exceptions, and I don't know whether they have a rule against rolling out or rolling back with the with this. I don't know if I forget what they're called, if they're called support nuts or support bolts or not, but they do put bolts in the vehicle support posts, because this is shuttle hardware. The shuttle used to be bolted down to, and they were called hold down posts in shuttle. Here they're called vehicle support posts because those bolts do not have to be severed at ignition and liftoff. In this case, when the vehicle's out of the pad, they take those bolts off of the vehicle support posts, and the weight of the solid rocket propellant all by itself, and then the weight obviously of the liquid propellant when it's fully fueled, keeps the vehicle down. But then you have this attachment. The vehicle stabilizer attaches to the forward skirt of the core stage. So basically, right at the base of where the conical launch vehicle stage adapter is where that stabilizer. It has two attach points, and it's holding on to the core stage to give it some lateral stability for those types of loads.
Yeah, that's what I was always wondering, because the one thing I loved about shuttle was the frangible nuts. I just found it such a cool idea that, of course, you have the support post there, but on top of it, you had a nut that would literally have an explosive in it that would split it in half, and that would allow the vehicle to then leave the pad afterwards, which, I mean, they pretty much all fired, but if one or two of them didn't fire, it wasn't as big a deal, because just how fast the rocket's going and the speed and the forces are just going to rip it off anyway. But those were massive. I have a photo of me somewhere holding one. They are massive and they are heavy, and yet they held down an entire shuttle stack. And now to think of having something even more massive, even heavier, not being held down with any bolts like that, it's just, I don't know, it kind of is mind-blowing to me.
Yeah, and in that case, you obviously had the orbiter cantilevered off the side of the tank, and so with an inline configuration probably helps to a certain degree that you didn't have for shuttle.
Yeah, that too. Also, a little bit of a lighter vehicle in comparison, even though, it still had the 4-segment solids and you still had an orange external tank, right. But yeah, compared to this, quite different. Also, different with the shuttle that I think is important to note when we talk about, issues with leaks and hydrogen and all of that, is it didn't bring the tower with it. This, again, you have the mobile launch platform, which includes the tower that you see there, whereas the shuttle used the fixed service structure. In fact, the exact one that is still at 39A. So I don't know if that changes things, especially with the roll back and the roll out, that you're kind of taking a lot of the ground support equipment with you too.
Yeah, and of course it's actually kind of funny to me because of how messy this all gets. So, at the end of the shuttle program, they had issues with the ground umbilical carrier plate, which was one of the connections that was not made to the vehicle until it had rolled out and been put down hard down on the pedestals of the pad. And so it's not exactly the same issue. And so that plate and that connection was only passing gaseous hydrogen boil off. And so the analogous umbilical on this vehicle would be the core stage intertank umbilical, which they're not seeing any issues with. It's the one at the bottom of the vehicle. The orbiter had its two tail service mast umbilicals, but it's a different design, different configuration. But in that case, they did roll out. They didn't make that connection until the vehicle was already at the pad, and then they still had an issue. And of course, it turned out to be they eventually chased it down, but I don't know that they chased it down until after the program had ended. And it had to do with the way that the plates on the external tank were aligned when they were being, in production. And so in this case, it's still sort of an unknown exactly what the root cause is. And I think, again, that's one of those bigger picture questions that I think we're still going to be wondering, even if they go through the workaround or the mitigation or whatever you want to call it for this vehicle, is what else they might do in terms of trying to find a root cause for this issue in between Artemis II and Artemis III.
I mean, I feel like at this point they're going to have to, and they have at least 2 years, depending on when this actually gets off the pad, to be able to figure that out. But we'll see if they do. And by the way, the footage that you saw there on the left, that was the rollout of the final space shuttle mission, STS-135. And also, fun fact, yesterday was the anniversary of the final launch of the Space Shuttle Discovery, STS-133. So kind of wild to think that that is the 15-year anniversary, I believe, of STS-133, which was supposed to be in 2010, but then that had its own set of issues that ended up delaying that launch by like 4 to 6 months. It was a wild thing. And by the way, you'd know about that if you followed us over on Facebook, where we have memories that come up on our Facebook page there about this day in spaceflight history. So that's a cool thing to check out. That's also where we're actually going to be able to answer some of your questions, with YouTube chat being, well, YouTube right now. We also have posts over on the NSFX page about the Artemis rollout. You can reply to that as well with questions. I'm monitoring both of them right now as we wait for YouTube to get its act together. Before we move on to more, though, let me thank some people that gave their support during the musical interlude, shall we say. R. Simmons, thank you for becoming a Red Team member. Jay Benfield, thank you for becoming a PadRat member. And High Risk, High Reward, thank you for becoming a PadRat member as well. Very much appreciate all of that. So at this point now, again, Rollback started a little bit before 9:45 a.m. Eastern Time this morning, and you can see by our very clever progress bar that it's only the final 10% or so to go of this journey. Which, how far of a journey is this, again, from the, I guess, 39B to the VAB, or other way around, depending?
I think it's a little bit over 4 miles, I think. If I recall, maybe 4.2 miles. But that's the number that I remember. Of course, it's English units. But that's the way I remember the distance from the VAB out to Pad B, and a little less to get out to Pad A. But I'm not even sure. I don't think you can get a crawler all the way to the shuttle pad at Pad A anymore.
You cannot. When SpaceX took over I believe it was a 30-year, was it a 20 or 30-year lease?
I think they're going to be there for a while.
Yeah, but as soon as they got the lease from NASA for 39A, they built their horizontal integration facility, which allows them to basically mate all the payloads, mate second stages to the vehicles, get everything integrated, add Dragon capsules before rolling it out to the pad, and then raising it vertical there. That is exactly where the horizontal integration facility is basically right on where the crawler way goes. So yeah, guests could get it to the pad. You would just have to drive through an entire building. So they don't want to do that. From this view, you can kind of see, you can see some of the RS-25 engines in the base there. You can see at least one of them. Hopefully that's not Engine 3, given the history had with Artemis 1 and Engine 3.
No, I believe that's Engine 4. Engine Position 4. So what is that? I have to go look at I wonder if I have that graphic on my computer handy.
Also,
but yeah, that's Engine Position 4.
I love that you can see the humans for scale on this. That is my favorite part, just how massive this vehicle is.
Yeah, I was lucky enough to see that engine section when it was it was just a naked barrel way back when. And it's big all by itself. It's 8.4 meters in diameter. It's probably approximately the same height. So it was a large beast even at the time.
It is absolutely massive. Again, just the tail service mast umbilical, as much as we've talked about that recently, just the scale of how big that thing actually is. It's like, oh yeah, it's just a little part of the stack. Well, when you realize how big the stack actually is, yeah, it's hard to describe the scale of it until you go and see just how massive it is. And especially when you can compare it to something like Shuttle, which was a lot stubbier in comparison. It was so much shorter. And then Falcon 9 is a lot on the skinnier side, so it's got some of the height, but super skinny. Then you add this behemoth where you have the width and the height of it. It demands presence, for lack of a better way to put it, for wherever it stands. And even from this view, it looks small, and yet, huge vehicle. I love it. It makes its presence known. All right. Again, continuing the rollback at this point, I don't think we really talked much as well about, the whole issue of getting this thing back and rolling it back. It's taken a little bit of time, given that they made that announcement on Friday, and now it is Wednesday with them rolling it back. Of course, they also had issues with weather in terms of having winds be within limits, because it was windy and freezing cold, at least for Cape conditions, the other night on Tuesday, so they decided to hold off on that. And speaking of someone who can talk about that weather and how windy and chilly it was, we have Jerry Pike, who's out in the field, and will hopefully be able to check in with us here on commentary. Jerry, do we have you?
You do have me. How are you doing, Sawyer?
I'm doing great. Good to hear your voice.
It is. I'm out here, yes, and it was definitely a little bit on the windy side the past couple days. There's a front that came through the Florida Peninsula the last couple days, and as we figured out yesterday, believe during that Starlink, yeah, it was pretty chilly by Florida standards. So if Ryan doesn't want to believe me, he can not believe me, but it was pretty chilly, if I have to say so.
Especially having to do it with your gloves off. How brave.
Oh, definitely, yeah. The fingers went numb.
And yet Max kept his hood on during launch, for shame.
Yes.
For those who don't know, there was a goal because of the people were saying, 15 or 14 Celsius is not chilly. Well, when you add in the winds and being right along the water and humidity and all of those conditions, it makes it feel colder. The feels like it may say, 15 C, but the feels like temperature is a lot colder. Just putting it out there.
Yeah, I'm not sure exactly what this temperature is in Celsius, but right now it's saying it's 69 degrees Fahrenheit with the 4-knot wind from the south. So definitely a lot warmer than it was yesterday and the day before, and less windy as well, for sure.
It's about 20, 21 degrees Celsius.
Yeah, so a noticeable improvement, I will say so.
Exactly. And the best part is, chat being broken, people can't complain about that and say, oh, you're wrong. So, haha.
Yep. Well, we're always right. Except when we're not, but we aim to be right here.
Except for that, yeah. Was that Jay Keegan?
It was. Chat might not be able to correct you, but I can.
I mean, that's if chat can understand you.
Touch it, because it's a balloon.
I mean, Jay, you got to go out there and experience it yourself. We need you to come to the Cape and then during this time of year and go, yeah, you're right. You'll understand when you're here. I thought the same thing the first shuttle launch I ever went to, which was in February of 2010. At night, it was beyond freezing. It was only in the mid-50s Fahrenheit, and yet it was beyond freezing.
The coast will get you.
The what will get me?
The coastal winds.
Yeah, exactly. And I was right along the Banana River for that, so that adds into it, and the humidity. And yet the first launch attempt was actually S-worded due to weather in Zaragoza, Spain. So I can blame Alex for the first launch scrub I ever saw in person. Yeah, for those who don't know, Shuttle had transatlantic abort sites that they would then go and land at if something happened. And there was ones along Ireland, there was ones in Spain, there was ones in Africa, all different places that if they needed to abort, they could have during the lunar flight. So just fun fact there.
It might have been the first launch that Alex, I guess we can say it. What is it going to do? Roll back to the pad? Scrubbed? But it certainly isn't the last, because I feel like every time that he comes to the States, there's a lot of those that keep occurring.
That is true. There's usually some kind of stand down for whatever reason or something happens. So, there we go. Taking a look at the shot, that shadow that we see on the base of SLS there, kind of working its way up past the tail service mast umbilical. Jerry, I believe that's the shadow from the VAB.
Looking behind me, yes, the sun is definitely going down behind the VAB. That would be the roof of the VAB here. I can see it a little bit better on that wider shot. I'm staring kind of directly at it and just see the shadow at the lower third of the rocket here on the crawler way. But yeah, that should be the VAB behind me.
That is so cool. Again, the vehicle assembly building, the largest single-story building in the world by volume. It is so cool. It's massive, and it has, what people I don't think realize is it has 4 different bays inside of it. So technically, they could have been working on 4 SLSs at a time if the program had actually gotten to a point like that, and would have been able to hold, and has held, multiple shuttle stacks that were being assembled at the same time. Because have you been inside the VAB, Jerry?
Yes, I have. We actually had the opportunity to go inside of it just this morning, and we were able to set some remotes inside of the VAB ahead of this roll in, I guess. So we will be picking those up tomorrow morning, and hopefully we will get some goodies over there, and we'll be able to see it also in the VAB itself tomorrow as well, which will be a really cool opportunity. So yeah, thanks to NASA for helping set that up the past couple days, but greatly appreciated for all this this access that we're getting.
Exactly. It's multiple different high bays in there. It's so cool. The fact that they allowed you to set up, it's weird. I've never seen set remote cameras inside the VAB for a roll. That's a new one. Because again, I keep saying shuttle days because it's just, again, that's when I was working in the media for all of it. But they would allow you up on one of the kind of catwalks up there to see it roll out in person. But I've never seen them allow remote camera setup in there for something like this. That is cool.
Yeah, I do believe they had something similar on one of the Artemis I rollouts. So we will see. We'll see what happens for the next roll out of Artemis II here. Should be hopefully soon. The sooner the better for this, I will say.
Yeah, which from a camera perspective, while I have you, I'm curious, how do you set up a remotely triggered camera in the VAB? Because for those who don't know, for launches, there are basically 2 ways you can do it. There is a timer, where if it's a set T0 and you know it's not going to push like an ISS launch, you can set it for that exact time because they give it to you to the second. Whereas if it's kind of a window, typically you are able to use a sound-activated trigger, and the sound of the launch itself, once it gets above a certain peak, will automatically trigger your shutter. How do you do that when it's not launching and it's not as loud?
So for this one, what I did, and I think a lot of the other photographers like Max as well, we just set up a timed intervalometer. So I set the camera to start in roughly 4 or 5 hours after we set them up around noon Eastern here. So it was just sitting there idling for 5 or so hours, and then the trigger came on and told it to, hey, start taking photos, and it will just keep taking photo and photo and photo until either the card fills up or the camera dies. So yeah, one of them is on a larger amount. So it's, yeah, I think one of them actually I started the entire way that was just on a battery with a large card. So it should be still clicking away up there.
And of course, we will find out and hopefully get some good shots from that. So if you're not following us on the socials, totally should, because once those pictures come in, we will absolutely be sharing those. I would imagine we'd see a couple of shots from that from you and Max.
Oh, for sure. Yeah, we'll be here bright and early tomorrow morning to go pick those up. So,
and again, we're on X, Facebook, TikTok, Blue Sky, Threads, Instagram, all of those. So you can check us out there for awesome photos and videos and information about everything happening in spaceflight. So now, again, it is about 5:41 p.m. Eastern Time. The roll continues. It's like the old days when it used to be work continues on the OLM. The roll continues for SLS. on its way to the VAB. I don't know if you can kind of get a sense of the vibe there, because I mean, obviously, there's a lot more disappointment on this, and I'm sure there's a lot fewer people out there compared to when you and I were out there for the rollout. I believe that was in January. I don't know.
Yeah, it feels like it was just yesterday, but I think earlier in the stream you were talking about this was over a month ago that this was happening, the initial rollout. There's definitely significantly less people here today. There's no I guess visitor center crowd. I believe that there was, like, right during that first rollout, there was hundreds and hundreds of people that they bust in from the visitor center that are definitely not here today. There's definitely less people. There's still a couple people that have tried to stop on the side of the road here and have gotten shooed away, but as it gets closer here to the VAB, but from a media side, not as much for sure.
And that is pretty wild there. Again, you saw the cop with the cars driving by. It's like, oh yeah, just passing on my way to work, driving by a moon rocket, rolling back. No big deal.
Yeah. It is very obvious that the shift change going on at 39A here, and there's a lot of cars driving back and forth, and they, again, work continues on the OLM, but work does still continue here at the Space Center, right? It's not the only thing that goes on here at Kennedy Space Center, so it's definitely a very busy place.
The world's premier multi-user spaceport, as they like to say.
Of course, I mean, this is evidence enough for that. There's still, hundreds of SpaceX workers that are coming in and out, just they don't work on this. Some of them I'm sure are working on Artemis, but some of them aren't. There's a lot of different, interactions here.
Yeah, there's still another Falcon 9 launch coming up in a couple days that I'm sure they're getting ready for, refurbishing the pad from the launch yesterday after another Starlink launch, 6-110 out of Slick 40 at the Cape Canaveral Space Force Station. All of that still going on. And just like, before when we had Crew 12 and Vulcan out on the pad in addition to SLS, it really is finally getting that definition of multi-user spaceport actually being multi-users and multiple things happening again. It's really nice.
Oh, definitely. Yeah. It's very nice to have a lot of different variety out here versus Falcon 9. That is kind of the, has been the go-to recently for what you see launching here at Kennedy Space Center. But it was definitely cool. Hopefully one day we'll have an SLS, a Starship, and maybe also a Falcon 9 out at the pad here at the Cape. So that'll be a nice, even a New Glenn as well. Add everything. More rockets, more better.
Exactly. But yeah, it's almost like that lizard. It's Falcon. But yeah, rolling back there, we also got to see a little bit of the water trucks doing their thing in front of SLS as it works on the way down to the vehicle assembly building along that crawlerway. The crawlerway, of course, uses special river rock that is designed so that it will kind of crush it. There we go. You can see the truck spraying as it goes there. So the entire weight of this whole vehicle and the launch tower, the mobile launch platform with the crawler and everything, it's a lot of mass. I'm sure you can understand. So it's a lot of pressure that puts down on it. So this rock goes a couple feet deep, and then there's additional mud and things below it that is meant to be able to withstand all of those forces and not basically destroy the ground underneath it. But it does crush those rocks. It basically turns them from rocks into instant sand. You don't want that sand and dust and stuff getting kicked up and then ending up inside the gears and motors that roll this entire vehicle, because these vehicles are old. They go back to the 60s. These are the same ones that would carry Apollo missions out to the pad. Apollo 1B, or Saturn 1B, Saturn 5, all of those. So it's old, it's heavy, and it's a lot of complex parts. You want that working, and you don't want that dust kicked up. So you can see there that spray truck spraying all of the rocks right in front of it to lessen the amount of dust and things as it goes by. Oh, that is so cool. I love being able to see this up close. I know Kevin Michael Reed got a chance to see this up close and personal. He was out there taking some photos and video, I believe, for something that is in the works. And they turned the water on. And he was a little close to it. Like, very close to it. And DOS. And they both got very, very wet. So, it's a lot of water. But right now, everything progressing along. It is cool seeing the spray truck doing its thing and all this going along. And you've got the cab on the crawler there. And there's just someone inside that cab that is doing the steering and turning and driving this vehicle as it goes. And then, of course, you have all of the spotters that are on the ground and around it, making sure that everything is on track and still working. You also have the teams that are on the deck of the launch platform there. And it's just, it's so cool to see the people. There it is. There's the cab. And you can see the person inside steering it. That is the what do you do for work? Oh, I drive rockets. Wait, what? Fly them? No, I drive them. And this is that drive. I love this view.
Yeah, I think they need one of those bumper stickers. This is my other vehicle is a, and then I guess crawler transporter. Is that the my other ride is a crawler transporter? It would be the right phrasing for that.
Or put something on this. My other ride is a Honda Civic.
Yeah. Yeah. That is a question. I wonder what they do drive like every day. Drive to work.
Yeah. I'm trying to think what's the
sure
slowest.
It's a difference.
What are the slowest vehicles that are on the road right now? And that's probably what they drive because they're not used to speed. But yeah, that's a great shot, by the way. That's your camera, right?
This is my camera. So yeah, we're multitasking here.
That's the name of the game when we're out there, folks. It's a lot of multitasking. It's yeah, taking videos, taking photos, doing commentary, but we love doing it. There's nothing else we'd rather be doing. And you can see that progression still going here. And again, the shadow of the VAB about to pass over the crew capsule up at the top. That is awesome. Of course, that top of the vehicle, though, is the whole reason that this thing is rolling back because of issues with helium in the ICPS, the interim cryogenic propulsion stage up there. Stage 2, basically, of this vehicle. Who would have thought, Jerry, that through all of the issues that we had, they finally fixed the hydrogen issue, and then it's helium? Yes, I agree. Here we go. You can see this awesome tilt up the vehicle there with the 5-segment SRBs. And then all the way up to that ICPS up there and that gosh-forsaken stage that is now causing us the issues. Which, a reminder, when it comes to the second stage on that ICPS, the issue was after 2 fantastic terminal counts in wet dress rehearsal number 2, all of a sudden, they went to then purge out the engine on the upper stage, and it wouldn't go. They used the helium to do the purge, wouldn't budge. They could get no helium into the vehicle from those systems. They're eventually able to at least purge it with help from the ground side helium systems, but yeah, it didn't purge. And that's the same ones that are used to pressurize the tanks to flight level. That's not good. You kind of need that. So as we take just a quick look at the base of it there, yeah, there it is. There's the troublesome system. Freaking helium. I thought we were done with that. It's like, oh yeah, let's blame hydrogen. And we even had the merch for all the blame hydrogen. Nope, now it's helium. Now it's got to be helium. I'm not mad, you're mad. Which, I saw this earlier on stream, and I legit laughed out loud because I thought of doing this, of getting one of the hydrogen shirts, and when it happened, just going, you know what, let me just make it helium, because this is absolutely ridiculous. So if you missed the Blame Hydrogen merch, well, now you can get the special limited edition Blame Helium merch. So, yes, again, the whole thing with more molecules, yes, helium isn't a molecule, but you get what we're saying at this point. So if you're just as angry as we are about helium being the one to blame now, you should go check this out at shop.nasaspaceflight.com. And I know so many people are like, well, methane doesn't have this issue. Oh, well, Starship doesn't have that issue with methane. Or New Glenn, even with methane, doesn't do that. I know. But NASA's using shuttle heritage hardware. So if you'd rather show your love for newer propellants than the old shuttle age stuff, there you go. Don't blame me. I voted for methane. There you go. You can vote with your purchase there on those stickers. Shop.nasaspaceflight.com. And even the guys on the right are waving at it. Like, look, that's pretty cool. Totally not just waving at the camera as we pass by saying hi. Oh my God. I love that merch design, just saying. That is so cool. I loved the shot with the waving people there. And oh my gosh, look at this sight-on view of the boosters. Could watch this all day. In fact, even listen to it for a little bit. Hey, let's listen in for a minute here. SLS ASMR. Stupid helium lines.
You can't type that in chat.
No. I mean,
Not
I'm
right
sure
now.
there's emojis that'll work for it, I guess. Look at that. Oh, that is a gorgeous vehicle. And I know we've been talking about the streaks that have kind of been added on the side there.
Yeah, you can see one of them there.
Exactly. That's why I figured this would be a good time to kind of talk about it. So what exactly are the streaks adding now that we didn't really see before, especially with Shuttle?
I think they probably had some, well, I'm sure they had some buffeting issues in the sort of transonic region as the vehicle transitions from subsonic to supersonic because of the, but this vehicle has, you have shocks coming off, especially off the pointy ends of the vehicle, and the way that those shock waves interact with each other produces turbulent flow, and especially it's between the solid rocket boosters and in this case, the core stage. And so they saw higher buffeting than they were expecting, and higher vibration levels than they were expecting inside the core stage, and measuring the G's around some of the avionics inside the inner tank there and elsewhere on the core stage. And so they added these strakes to try and mitigate some of that turbulence that they see in that part of the ascent, which is around the 1 minute point in flight. And so that's what those are there for. And they looked at some of these. They looked at different configurations for the solid rocket booster nose cones, and adding fence. I think they called them fences in some configurations. And after this they settled on adding these strakes. So there's a set on there's a total of 4 of them. They basically flank each end of the solid rocket. There's 2 forward attach points, so they're on either side of each one of them. So there's a total of 4 strakes on the forward solid rocket booster to core stage inner tank or core stage attach points.
And again, we could see that shot from Jerry there a moment ago as we look at the strakes there as well. We talked about the wiggle and the wobble on the rocket from the vibrations as it rolls. You could really see on that launch abort system from the different angles of just how rocky it is. By the way, in case you didn't know, that section is loaded of the SRB segment there. I don't know what gives it away, but I think that one's loaded. But yeah, if you look up at the top at the launch abort system, that thing is wobbly, like we mentioned. You could a little harder to see now from the angle, but it's got that shake to it, which is surprising. Again, people don't realize that it moves and wiggles a bit as it's going.
And you could see that. You could see that during shuttle rollouts too. If you look at if you looked at the top of the tail of the orbiter, you would see the same thing. I remember especially when I was a kid looking at some edited video of the STS-49 rollout with the first flight of Orbiter Endeavour, and I think they were taking some pictures of a couple of the crew members who were standing on the mobile launcher platform, and they were standing in that area, and you could see the tail sort of bobbing up and down. It's like, wow, that thing really moves around.
Oh yeah. And speaking of seeing it move around, look at that. That is an awesome view, and this is from Max Evans, who is located on the other side of the crawlerway. Again, thank you to NASA for providing us that opportunity. So you have Jerry, who's on the south side of the crawlerway, and Max on the north side of the crawlerway. You can really see that wiggle there. That is spectacular. Goodness gracious. That is a beautiful vehicle. It still boggles my mind that this thing has launched once and will launch people to the moon on this. I don't know. I want to say monstrosity, but I also want to say beauty. I don't know if there's a way to kind of find a happy medium between the two. But yeah.
Beautiful monstrosity? It could be both.
Yeah, fair point. It very much could be both. Also just blows my mind the amount of wiring and tubing and piping and everything on that mobile launcher. We could see it a bit from Jerry's angle earlier, and even now, just all the structures going into SLS that are riding up that massive 200-plus foot structure there. It just boggles my mind that someone's job was to go, yeah, we're going to put all those pipes there. It's so amazing. But there we go. You can see the roll continuing now. Just about a little over 8 hours after the roll began, already up to this point, near the Launch Complex 39 press site, getting closer to the VAB. So right now, again, the hope is that we can see this thing launch in the beginning of April. Is there still a chance maybe of hitting the end of that March window, or do you think that's completely out of the question?
It's completely out of the question. Yeah. I was saying elsewhere this morning that just the act of disconnecting the mobile launcher from the pad services and just having the crawler transporter lift it up off the pedestals added 2 weeks worth of work too. So if they had just set it back down and plugged it right back into the pad, they'd have still had 2 weeks of work to do on it at minimum to get it ready to launch, and that's without considering the issues with the hydrogen tail service mast umbilical and that especially. So yeah, they I think the last possible date would be March 11th, and they would be challenged to do that, even setting aside the whole issue of the hydrogen leaks.
Yeah, because I think a lot of people also don't realize that, yes, sure, it is a mobile launch platform, but there are still a lot of ground-side connections that need to be made, both in terms of commodities, such as the propellants, the helium lines, the oxygen, the hydrogen. All of that still has to come from somewhere, and it does come from the ground into the pad. And then even little things like the slide wire baskets that are there in the event that the crew would need to evacuate on the pad. Instead of using the launch abort system, they have these kind of slide wire baskets that they hop in that will take them away from the vehicle anywhere speeds from 30 to 50 miles an hour. And then at the base, they have these basically military strength vehicles that they hop inside and can drive away to safety. They had to, even for this rollout, lower them all the way back down, disconnect the lines, and then they're going to have to reconnect the lines, reattach the baskets, and retest them again, right?
Yeah, they basically have disconnecting things and putting them away takes a lot less time than connecting everything and then going through the test and checkout to make sure that they work. So when you're disconnecting stuff, you don't have to check you don't have to check to see if they don't work. You just disconnect them. So if you recall, when they rolled out to the pad, they rolled back out to the pad on January 17th, and even though the weather prevented them from making the first wet dress rehearsal attempt, they were ready to start the countdown on the 29th and do the tanking day on the 31st. So with they worked really hard to get that preparation, which is a good portion, probably 75% or more of the work to get the vehicle ready to launch in that 2-week period. But it also speaks to how much work there is, and that they're going to need to do about 2 weeks worth of work when they get back out. One of the things that I believe that they do not have to do, that they just left on board the vehicle, was the solid rocket booster hydrazine, which helps power the hydraulic systems for the boosters to move the nozzles and steer the vehicle. And so that'll save them a little bit of time, but then there's still a good part of 2 weeks worth of work when they get back out to the pad to get the vehicle back into a launch configuration, and then from there, then they can start looking at things like tanking tests.
And that's a good thing you bring up with the SRBs, because one of the big issues of the Artemis 1 campaign was the battery life on the flight terminal. All right, we should be back now, folks. Let's go ahead and blame helium for that, okay? Let's blame helium, because that's the theme right now. But anyway, what we were talking about before technology decided to be technology was the fact that the SRBs were a big factor. I mean, during Artemis 1 campaign, there was the issue of the flight termination system batteries and getting the qualification and certification for that, that they had to keep getting extensions while it was out at the pad, since they couldn't really do much out at the pad with it. Then they had to roll back, and for other reasons, and while they rolled back, they were able to use that to kind of recertify and recheck and retest and do all the battery work that they needed to for that FTS for Artemis 1. For Artemis 2, they specifically made changes so that they could access certain parts of the vehicle and certain things at the pad and not have to roll it back. Was the FTS one of the things that they could do, and was that something that they did do out of the pad, or is that something they're going to now do once they roll back? Because we did see some of those structures that they used to be able to access the vehicle out at the pad up against it right before they rolled back.
Right, and they actually got the first of the two platforms into place, and then the last step to securing it would have been to set up the support cable so that, to kind of like we were talking about with the vehicle during the roll here, but there's a support cable similar to the crew access arm that helps stabilize it for wind loads. But then they got the news about ICPS, and so they were getting ready to do the flight termination system reset out at the pad. But what it sounds like in the update that we got yesterday is that they're going to, because they have better access in the VAB and they have to do it anyway, that they've opted to do that in the VAB. And so one of the things that you avoid is, because it's indoors, is and they talked about this with the delay in the rollback, was that or maybe it was just the delay itself, but the platforms are okay when they're completely secured to the mobile launcher umbilical tower with that support cable, but in terms of lifting them, you have to have much better weather conditions in terms of wind, or either to lift them into place or to take them down. So this avoids some of the weather conditions that you have in terms of just setting up to do that type of a test. But, again, I think that, the big question we're going to have is how much work are they going to do in the VAB, and how long is it going to take for them to get that work done in the VAB? Because they do have, we were just talking about, they worked really hard to get the vehicle ready to tank within 2 weeks of rolling out to the pad. And even though they have a few tasks that they aren't going to have to repeat, it's not clear. It's not clear if 2 weeks is going to give them enough time to squeeze a tanking test in there, in addition to all of that other stuff. And so I think we're still wondering how much contingency time or schedule margin they will have when they get back out to the pad, because as we get into March, I think that the seasonal patterns down there in Florida are going to change from maybe cold to maybe a little bit stormier weather. They could see a little bit more severe weather, I think, out there in March than they would in January or February. So, I don't know how lucky they got with the weather this time, but they may need a little bit of additional margin when they go back out. And so I think Max has got this shot here, and so this is we're looking at engine one, and I think somebody had put up I think it was Ryan had put up the graphic with which engine was which earlier. So engine 4 was actually the engine that had been replaced. And so that is now engine 2061, but I think engine 2047 is the one in the number one position. Yes, and then behind it, you can I think you maybe can or talk yourself into believing you can see maybe just the engine mounted heat shield blankets for engine 3 would be to the left of the one that we can see there. That would be engine 2059, and then the one that, and then engine 2062 would be way behind. There you go. So there's that graphic.
Yep.
So yeah, they had the issue
with thermal blanket there.
Yeah. So we're the one that's obviously in view is the engine 1. Is the engine 1 thermal blankets. I'm just trying to grab this one thing here, but and you can see those people there for scale. And yeah, this is they're the closest to the liquid oxygen tail service mast and the umbilical plate for the on the engine section. And you can see a little bit of some of the other things you can see there to the left of the engine blanket. You can see the aft solid rocket booster separation motors. And you can see one of the aft solid rocket booster to core stage attached struts. I was ready to say ET to SRB attached struts. And you can directly above the engine blanket, and you can sort of see the outline of the fairing. There's one of those onboard cameras that it's basically looking up the stack to the top of the vehicle, and they have those cameras are record or are transmitting down live to the ground. I think we would probably have to have a daylight launch, which I believe we would have only the opportunity on the 1st of April to get. So we would have to get lucky again, kind of like that tantalizing March 3rd opportunity that was there for a minute and a half. But I don't know if we're going to get to see that, except maybe in recording, like on Artemis 1, unless we had a daylight launch. And I think they might be willing to show that to us in daylight conditions, either during the early part of the launch or maybe even during the later part of the launch if there's enough light. But and then right at the line between the foam and the white, which is paint, you can see one of the vent holes for the engine section. And so there, we talk about purges, and one of the things, yes, thank you, that helps make it more clear, that one of the things that they're doing, especially when they're in place either in the VAB or at the pad, is they're keeping those environments as environmentally controlled, so temperature and humidity. But then when they tank the vehicles, they're purging those with gaseous nitrogen, and you can sometimes see that venting during the tanking process. And the temperatures inside the engine section still get really cold because there's a lot of liquid hydrogen circulating through the lines in there, and even though the lines inside them are covered with foam as well, unfortunately we can't see them because of export control. But they were saying that the temperature inside there still gets down to around 0 degrees Fahrenheit, so still pretty chilly in there.
0 Fahrenheit, not 0 Celsius.
That's right.
Wow. Just, again, the scale of things there, and hopefully we would see that view. Also worth noting that, as you saw from the graphic, if it does push to the 30th, which is I guess technically the May window at that point, that is also a daylight opportunity there at 6:06 p.m. Eastern Time if it goes in the early part of that window, because, again, these are 2-hour-long windows for each of those, although it does switch to daylight saving time in the U.S., so that does improve the chance of it staying lighter later and getting to see more of the vehicle on ascent. As much as it would be nice to see it go in that early April window, part of me also wants to see, the daylight launch now, especially now that it's back on the table. It's an opportunity again.
Right. And the closer we get to the northern hemisphere summer solstice, the more daylight launch opportunities there will be. So we'll start to see we'll go from one day with some daylight window to and the flip side of that being like in February, where all of the launch windows were completely in darkness. There will be some months. I don't think NASA wants to wait for that, but there will be some months around the summer solstice where the launch windows are all daylight. So, but that is not a requirement for NASA to launch the vehicle. They would be. I think they would have been happy to launch at the beginning of this month if everything had lined up for them.
Yeah, or even March. It's worth noting then that the timeline for that, as you pointed out, the day launch condition is not the issue. There's a couple of issues that they have to keep in mind when it comes to the launch windows themselves and why they're so few and far between. Part of that, of course, is the location of the moon. Part of that is the lighting conditions that they would like to be able to see when they get to the moon. But most importantly, a lot of it has to do just with Orion itself, and both the needs for power, given that it is a solar-powered vehicle, and I believe some of it was also to do with reducing the amount of thermal load on the heat shield for parts of the flight as well. And if I recall, part of the requirement for these windows is that the vehicle would not be in darkness for any period longer than 90 minutes at a time. Am I remembering that right?
Yeah, that's the maximum that the vehicle can be in eclipse, for with margin, I would imagine, for the batteries inside Orion can sustain the vehicle for that amount of time with incomplete eclipse. And so it really has to do, as you were saying, with the electrical power system and its solar. The batteries are recharged with the solar panels.
Yeah, it's very different from shuttle. Again, I'm going to keep bringing up shuttle because you've got 2 shuttle people on stream here. Of course, we're going to. Shuttle was primarily based off of fuel cells. There were multiple fuel cells, I believe 3 of them inside the orbiter, including backup systems and whatnot. But a lot of the issue there as well was the radiation of the heat from all of that was created. Of course, you could use the water that was created as a result of it, which is a benefit, but then you had those giant payload bay doors that would open, and attached to those were radiators. So those doors had to be opened within a couple of hours of launch maximum to be able to start radiating off that heat. And that was one of the last things they would do before reentry is close them to try and get the benefit of those radiators as much as possible. Not as much of an issue with the small capsule here, but also part of the reason why Shuttle had those giant radiators was with the fuel cells and being able to be in darkness for longer periods of time, whereas this is a whole different ball of wax.
Right, and of course the fuel cells operated on hydrogen and oxygen themselves, and so the orbiters had, I think some of them had up to 5 sets of PRSD load. What is that? Power reactant storage distribution system. And then the extended duration orbiter kit basically had a pallet at the back of the payload bay, which Columbia used most of the time for to basically extend the amount of consumable supply for the fuel cells. And so one of the limitations for shuttle in terms of how long it could fly solo was how much of the cryogenic supply they had for the fuel cells.
Yeah, it's a little different once you're up at the ISS because then you can just hook into the ISS power supply. That's still what Dragon and other visiting vehicles do to this day. Is as soon as they dock, some of the lines they connect allow it to hook into the ISS's power bank, so to speak. But yeah, that also, again, given that it was hydrogen and oxygen, that also meant you got free water out of it.
Right. Yeah, this spacecraft Orion has to bring along. So you have the electrical power is renewable, but the water is a limiting consumable. In addition to they have others like oxygen, for instance.
And it's worth noting as well that for Artemis II, this is a major test of a lot of those systems because Artemis 1, sure, it had the upper stage attached to it, the European Service Module, but it didn't really have all of the full life support systems on it and running and active that we will for this launch because the crew of Artemis 1 was, a moonican and 2 torsos. So it wasn't really living human people that were breathing or anything. So this is the first time that we'll get to see that full ECLSS, the environmental control and life support system, in action, which is both cool, but also a little almost slightly concerning, the fact that, yeah, we're going to test out the full life support system with the crew of 4 going around the moon, as opposed to earlier.
Right, but then that's the reason that they're staying in a high Earth orbit for the first 24 hours of the mission. Is that's the risk reduction part of the trajectory, the flight profile, is rather than go straight to the moon 90 minutes after liftoff, they'll defer it for essentially 24 hours, and the activities on flight day 1 will give them the opportunity to see the environmental control and life support systems that they added, and all of the crew related systems, how they function during the medium load, and then they're going to do a little bit of an exercise. They're going to do some limited exercise, I think, when they get up on the flight day 2 before the translunar injection burn. But I think a lot of them have talked about they think they're going to have a decent idea about how well those systems are performing before the crew goes to bed on flight day 1.
And what's also going to be cool in that early flight days while they're still in orbit around the Earth is the rendezvous proximity operations. So basically, Orion is not going to be what they use, obviously, to land on the moon. And unlike the Saturn V days, where it brought the lunar lander up with it, and then it would just kind of detach, spin around, and dock to the vehicle inside one of those upper stages, you're going to have to launch another vehicle to it, which, as of right now, is currently planned to be Starship. But again, given the whole mandate to try and see who can go faster, there's always the chance that it still could be Blue Origin Mark II lander. But regardless of that, it's going to have to dock with another vehicle at some point. So this is kind of a way to test that out, of being able to maneuver the vehicle, spin it around, test out those onboard thrusters, and see how it actually behaves in an in-space environment with the crew manually taking the controls of it. Because I don't think we know yet if it's going to be an automated or manual docking to whatever their lander is, do we?
I don't know what I don't know what the crew for, I guess, suppose Artemis 3 will choose to do for the final sequence, but the requirement for Orion is similar to Dragon and Starliner, is fully autonomous rendezvous, proximity operations, and docking. So in this case, I don't know how much of the software. I mean, there was a debate way back when they talked about adding this demo. This mission Artemis II has existed for over a decade. It wasn't called Artemis II back then, but this is the proximity operations demonstration is one of the last things added to it, and I think the idea is it's a handling qualities test in addition to a manual. It's a manually piloted demonstration, and the idea is that it gives them data on the pilot making inputs into the flight control system, because this is another fly-by-wire vehicle, of course, and so you get to see that feedback loop between putting a piloting input into the flight control system, and then it gives you what it as best can figure out what you asked it to do, and then you see if you have any you see if how they react with each other, and if you have any, do you get into any feedback loops or anything like that. And so this will give them some additional data on how the flight control system handles the inputs for that.
Exactly. And that's pretty much the thing that they do for all new vehicles as well, is to be able to test how it hand flies. As we saw with Starliner, that became a little more critical than anyone had thought, with being able to have to take over manual control and the whole 6 degrees of freedom issue. And that's again, whole nother story. Starliner is its own can of worms, but that's part of why you test out those thrusters and everything ahead of time, usually before a major significant mission milestone. So that is something that they will be doing as well during the flight. And then, of course, it's worth remembering that this is not an orbital mission. This is a free return trajectory. So unlike Artemis 1, where they actually went into a distant retrograde orbit around the moon, this is basically a figure 8, akin to what we saw during Apollo 8, where it's going to go out, swing around the moon, and its trajectory is basically, if something were to go wrong and the thrusters would ever stop working, it would put you right back on a proper trajectory towards Earth. Obviously, we hope that never happens, and it'll be a good way to test out, again, those maneuvering thrusters, the engine burns and things, of making those course corrections along the way, and seeing how things operate out in the lunar environment with people on board. So a lot of this really is a big test. It's kind of a mix, I feel like, of Apollo 8 and Apollo 10 in this mission, of testing out systems, doing the flyby around the moon, but also putting as much of your vehicle into testing as possible without actually landing, and without actually, honestly, having a lander too.
Yeah, and the free return is another risk mitigation, given the fact that this is, for this system, this is the crewed demo, and Artemis 1 was the uncrewed demo, and but this is still both a crewed demo and the first crewed flight test of this system. And so, first time you're putting a crew on board, you take maybe a little bit you're a little bit more conservative with what you're willing to do. And they talked about that during Artemis I, about the flight plan for that mission being being a little bit more aggressive with taking risks, going into a lunar orbit, or a type of lunar orbit, because they did not have crew on that flight.
Yeah, those little meat bags that have to breathe and eat and drink and all of that, they kind of add a little more complexity to these missions.
Yep, and so one of the things that they're thinking about all the time on this mission, especially because it's the first crewed mission, are their abort options. Ideally, you would have abort options that would reduce the amount of time it takes to get back to Earth. But once they make that translunar injection burn, there's a period of time after that where they're going to be committed to basically a week away from Earth. And so that's one of the things that they're thinking about is by doing it this way, where you have the upper stage, the ICPS is still doing a huge percentage of the TLI burn. It's just that it stops short of completing it. Is that even though Orion's doing part of that burn, it does still have enough propellant supply to do some types of abort burns that maybe not be a direct abort burn, but it has some additional capabilities to shorten the amount of time it takes to return to Earth in some cases. But obviously they're hoping they don't have to do that, but it does give them a little bit more, again, more of a conservative approach to this mission.
It's all about that risk mitigation, especially considering that there isn't another interim mission scheduled in between. It's not like you can add in an Artemis 2.5. The plan is Artemis 3 will be a lunar landing. So you want to have everything figured out and get all of your testing done here. And that lighting, absolutely gorgeous as we approach sunset on the Space Coast. And SLS, Space Launch System, for Artemis 2 getting that much closer to going back inside the vehicle assembly building. It's coming up right now, in fact, on that little curve that we were talking about earlier, that is a mostly straight shot, except for this one little kind of C-turn that it ends up doing here. And I think it's interesting to note, because, we're used to seeing one crawlerway. This crawlerway is all different kinds of paths and crisscrosses and things, because you have one that went to 39A and one that went to 39B, and a tiny little piece that was starting to be built for 39C, even though 39C never really became a thing. But it's also worth noting that there are 4 different high bays located inside the vehicle assembly building, and each of those needs a way to be able to get out to the pad. So, Philip, there's technically 4 different kind of little crawlerway paths that you can take to get vehicles in and out of all of those different high bays, right?
Yeah, you know what? I'm taking a quick peek at Google Maps to see if the one exception would be High Bay 4, I believe, but and there was probably a time during shuttle where both of the west-facing high bays were not the crawlerways were not all the way hooked up to the high bays, but of course now High Bay 2 is dedicated to core stage integration. So Boeing's taken that over, and so now we don't have that. But at the end of shuttle, they had actually opened up the High Bay 2 crawlerway. So you had driveways for High Bays 1, 2, and 3. And then I think looking at this now, I think at some point a long ways back they stopped. They paved over the crawlerway entrance to High Bay 4, because that's been used as a support cell, so to speak, for a long time. They used to use it for solid rocket booster stacking preps, and now they use it for SLS that way. But they used to do even more work. A lot of the work that they do now in the rotation processing and surge facility buildings was originally done in the VAB. So, and I think High Bay 4 has been like that for a long time. But they did renovate High Bay 2 at the very end of the 20th century to be a hurricane shelter for a third shuttle stack, and they did have occasion to have a third shuttle stack being built up while the other two were either in the process of being built or at the pad. And if you had some sort of a tropical storm, you needed to get everybody back inside, you might need to do a little bit of shuffling of vehicles around those 3 high bays.
Yeah, and so which high bay is this one going into? This goes into, is it 1 or 3?
3. So,
Okay.
and yeah, so the little jog that it has to take is to go into High Bay 3, but it is interesting. I believe, going back to, I'm not sure about Apollo, but I know that the first shuttle vehicle was also built up in High Bay 3, but then they were able to put together vehicles. They used High Bay 3 and High Bay 1 frequently, and especially when they had a flight rate that was up around 6, 7, 8 a year, they were using those high bays, and then maybe towards the end of the program, they as we talk about these, a lot of these facilities are 60 years old. You would see towards the end of the shuttle program, they would take one of them offline to do maintenance and then rely on the other. And there were fewer periods where both high bays were active at the same time, and you had the same issue with the launch pads too. They would sort of alternate maintenance windows and maintenance periods on the pads and the high bays. Again, just because of this older infrastructure that they have at the Kennedy Space Center.
Yeah, I mean, 1 and 3 are definitely the easier ones because 1 is a straight shot. 3, it's on that little curve, which is basically what SLS is on at this exact moment as we speak. It's starting to make that little curve there. If you had to go from one of the backside high bays, that one is an entire loop that you would have to then make all the way around the time the orbiter processing facility area would pass right by that. Currently where the Starliner facility processing is, also by where they're currently stacking up Mobile Launcher 2, there's a whole path that goes around the back there. So they prefer not to do that. And I remember when they were doing the VAB renovations after the end of Shuttle, the amount of copper wiring that they yanked out was unbelievable as they upgraded things to more fiber optic and modern cabling and data transfer. Just to see where we've come from with Apollo to Shuttle and now to this. Again, going kind of back to that old school style with the big mobile launch platform, the giant launch tower, and yet still using the exact same Apollo era crawler transporter to work its way to and from the pad, in this case, unfortunately, from the pad with the rocket still atop it. I absolutely love the history of these. Of course, they've made many upgrades and modifications to these as well. It's not all the same equipment from the 1960s, but a lot of it, Philip, still is.
Yeah, obviously the vehicle assembly building itself is preserved to some extent. They have had to do renovations on it. Obviously, there was a rash of hurricanes about 20 years ago, where it looked in pretty bad shape, and they did have to spend some money to renovate the facility, the roof, and the siding. And they've probably spent some money on it, but it is interesting. It is interesting how much money goes into the flight hardware, and then how much money goes into the infrastructure. And it seems like the infrastructure ends up kind of being they get the last pick. They get to pick over what's left over in the money tray at the very end.
I like that. Just getting what's left over. And as we look up the SRB there,
You can see both of the liquid oxygen feed lines.
And also
the
that kind
core
of
stage.
stabilizing arm that we were talking about too earlier.
Right, that's the vehicle stabilizer right there. And then there's the ICPS umbilical, and then the Orion service module umbilical, and I guess it's a little bit harder with the light to see how much the vehicle is swaying now. But it's still a spectacular shot.
Oh yeah. And again, the darn ICPS and the helium, it's still, the rocket was ready. The wet dress rehearsal was beautiful. And we have to blame helium. I'm not bitter. You're bitter. Which again, don't forget, very limited edition. As we deal with helium, hopefully we never have to deal with it again. We do have the new Blame Helium merch in the shop. So for those who wanted the Blame Hydrogen, it was limited edition. You missed out on it. Well, you can kind of get the shirt because it's basically Blame Hydrogen. Just cross off some parts of it and add an E to it, and you get helium. So you can check all of that out in the shop as well. Shop.nasaspaceflight.com. Any excuse to blame a molecule, element, whatever, atom, whatever you want the proper terminology is. Also, I am trying to understand chat right now because it is kind of semi-working, but it all involves umlauts and other foreign characters, and people appears to be speaking in German. Adrian's not here, so I don't get as good a support with that. I speak French. I don't know if it'll allow, accent aigu and accent grave and all of those, but yeah, the YouTube chat has been wonky this afternoon and evening. So that's why we're really not able to take as many chat questions, because chat isn't able to ask as many chat questions. Of course, the shop still works. You can still add messages if you get something from the shop. Also, keeping an eye on the chats on both the Facebook side, if people have questions, as well as over on X. I'm checking all of the posts that are related to Artemis that NASA Spaceflight has been posting to see if there are any comments on those, other than yelling that it was not a pan up, it was a tilt up. So, if you want to ask some questions that way, I am trying to keep an eye on those as well, so that we can get some of your questions answered too, because I know that's part of the fun of this, is being able to chat with all of you. Hey, it worked. There we go. I'm seeing some people in French. Nice. Again, apologies people that don't speak French, but it helps me out a little bit at least. Décollage. I love, again, the sense of scale when you see the people moving around on the deck. That person right there by the SRB. The size is, it's... Again, I was talking about this earlier, but it's hard to wrap your head around just how big all of this is. Even right in front of the screen, that's one of the water deluge pipes as well, right? And those are pretty big, especially with the amount of water that they have to place underneath the launch pad in such a short amount of time.
Yeah, that's one of the rainbirds. You can see, I think if you look on the side of the mobile launcher deck, I think those pipes are on the other side, but there are some really large diameter pipes, and those are, I believe, for the water. And so that's another one of those services that the pad provides to the mobile launcher when it's out there, is the water for both ignition overpressure protection and sound suppression, and fire extinguishing water as well, I believe, is supplied by the pad.
Yeah, that's one of the things that, when, especially during shuttle program, NASA PAO would always call it the sound suppression water system, which, yes, it is sound suppression, but it does more than just the sound suppression, like you were talking about, with helping to negate with pressures, to help with the pad after it lifts off to prevent any additional fires. Is a lot more to it than just sound suppression, but the sound suppression aspect is very important, given that the vibrations that are created during launches are quite massive, especially with these RS-25s. They are very, very powerful engines, and they can shake a bunch. And I guess it's a sort of a safety feature there, not because it's too loud, but because of the acoustic dampening, right?
Yeah, both the liquid engines and the solid rocket boosters, they are. Oh, that's a really nice shot.
Oh, that's beautiful, looking into the high bay.
Yeah, but yeah, it's they're I think the way that they put the water on the mobile launcher for this, there's a deluge that's going into the flame trench, into the flame hole to dampen the acoustic energy from the engines while the vehicle's still sitting there on the pad. But then they deluge the entire mobile launcher deck, and they have these butterfly valves that open at specific times so that that last full deluge is running as the boosters start, and then the vehicle climbs away, and you're trying to. I think they still ended up there. There's only so much that the sound suppression and ignition over pressure protection can do. So obviously on Artemis 1 there was still some there's still some work that they learned that they needed to do in terms of beefing up the structures and beefing up the protections on the tower and on some of the pneumatic pipes that you can't deluge with water.
What? It's not like it blew in an entire elevator doors, destroyed a bunch of the elevator shaft that was on this mobile launcher. Right. No, that totally didn't happen.
Right. And if you remember some of the videos that the guys got from their remotes when looking at some of that stuff in slow motion and looking at and for that first launch, that you had you could visualize the shockwave from the boosters when they started, and it really gave you a sense of how much energy is coming out of the vehicle when it starts and climbs away from the pad. And so they did have to beef up. They did have to beef up the some of the pneumatic lines. Had to replace a lot of them, and so one of the things that happened. So the elevator doors are not great because it made access. You had to basically use the stairs, but in terms of damage to the umbilical tower and the mobile launcher, the hold down, or not the hold down, but the support posts and all some of the equipment on the deck, because the boosters, one of the things they damaged is they broke some of the pneumatic lines, and those lines are using nitrogen, and so they could not only did they lose that pressure to do the automatic wash down of the mobile launcher deck, because the solid rocket booster exhaust is very acidic and very corrosive, and so that was prevented by that damage. And then that, because you also had a nitrogen leak, then people could not get to the pad to get that washdown done. It delayed that even longer, and so you ended up with a huge amount of corrosion to the piping because they weren't able to get those pad washdowns started. And so then that increased the scope of the damage and how much of the piping they had to replace.
Yeah, that's kind of the annoying part as well of having to go up a 300, the vehicle's 320-ish feet tall, having to go up to the stairs all the way up to the top. The crew access level is the 280 something foot level. I'm trying to remember.
Yeah, I think it's 274. But yeah, I mean, that was the thing, is like I think I can't remember how many days it was, but that was one of those things we were thinking is like, we're watching the videos that were shot from the press site and looking and going, wow. And then they weren't able to open the pad up for several days because they had this, safety hazard of you've got leaking nitrogen because of the damage to the pneumatic systems. And I think it took, I can't remember, I don't think it took a week, but it took several days before they were able to let the photographers go into the pad and pick up their equipment.
Oh yeah, that was longer than the photographers I think expected. We expected maybe a day or so after. It was I think 3 or 4 days, if I'm remembering rightly.
And that was a side effect of the issues that they had. And so they've put in measures. They had to replace all the piping and repair all of the corrosion damage, and obviously have tried to put in mitigations for all of those issues that they saw. And so now we were, I think, hoping to see how it performed here by now, but we're going to have to wait another month and change, it looks like.
Yeah. But you could see it there going into High Bay 3 there, of which there was a public address announcement report asking ML crew to report to stations in 60 minutes. So hopefully getting in towards that last hour of the roll. Hi, Max. But it's worth noting, might as well be a good time to talk about the High Bay a little bit as we can kind of see into it. I mean, they have massive work platforms inside of there. I believe there's EFG, what is it, 10 different levels that they are able to access, 10 different work platforms, if I'm remembering rightly.
Something like that. Let me see if I can pull that up.
I believe it's platforms A through K, if I remember.
Something like that. Yeah, I think you're right. The ones that they're going to be focused on, and I guess that's going to be sort of the general question is what's the scope of the work that they want to do while they're in there, because they have to balance against the more work that you do here, the longer you're in there, and it reduces your ability to make the beginning of April. So the platform A is they're designated from top to bottom, and so yeah, platform A is up around the launch abort system, right around the where the abort motor nozzles are, and then platform K is down right above the tail service masts, where the solid rocket booster, the aft solid rocket booster to core stage attach points are. And I think where the work that we're all going to be interested in is going to be probably platforms C, D, and E around the launch vehicle stage adapter, and then platform F is where they'll be doing the flight termination system reset.
So it is all within that middle part of it there, and you can kind of see some of it in there. You can still see a lot of the crane action that was built into it to be able to actually move the shuttle orbiter around and stack the shuttle during those days. I believe part of it was also used to stack SLS too. And now we're waiting for the crew access. Oops, sorry, go ahead.
Right. Exactly. So that's we're getting some severe hint dropping by the production team, and that's what we're waiting for here, I think, or very soon, which is they have to extend the crew access arm in order to roll into the VAB itself.
Yep, and so that's what we're about to see, it looks like, because it's one of those things that once they're inside, it's a lot harder to move it in and out, so they keep it away from the vehicle for the roll. And why is that? Is that kind of just so it doesn't keep bumping into it and cause any potential damage? Is that why they would keep it locked into place?
Yeah, so I mean, you see how much the tip of the launch abort system tower is moving around, and you have the same thing where in this fully retracted position, they can lock it into they can secure it more tightly to the launch umbilical tower. And then the problem is that once they're inside, they can't move it. They can't swing it through the full range of motion. So you got to pick one, and it's more useful to have the white room access to the vehicle inside, so they extend it.
Yeah, and it was nice actually, at least during the wet dress rehearsal too, to be able to see inside the vehicle assembly building as the closeout crew was doing their job, getting both the Orion hatch and the launch abort system exterior ogive hatch all closed up. And then looking down at the pad and seeing that procedure, it was so nice to be able to see that. And so now we look for first motion on that crew access arm. So at this point, they are holding in position there so that the roll is paused. That percentage bar is going to stay at 99% for a little bit as they get ready to swing that crew access arm back into place, which, I mean, they can move it very quickly, as we saw on launch day. And in terms of retracting it, it took them only a couple of minutes. We'll see if they go about the same speed or if they go a little bit slower. Because I know for during the roll out, they started to retract it away. They held for a bit, then they moved it back in and back out again before finally swinging it all the way back to the lock position to continue that roll out to the pad. So we'll see what they do. Let me just thank someone here really quickly. Some stuff is actually managing to get through. Very sporadic, but some of it's getting through. Doug J with the $10 tip at tips.nasaspaceflight.com talking about the me being bitter about all of this. You're bitter? My vacation is now Artemis-less. Boo. Still going to KSC, though. Maybe they'll open the doors. We'll have to see. I mean, sometimes they have the doors open. Occasionally, they'll have just a couple of the doors open, like one or two at a time for ventilation. But I don't think we would see the doors fully open until launch day or until rollout day, right, Philip? We may see just some sporadic doors opened for air.
Right. I that typically is what they'll do. They don't need to open it all the way. That might be a little bit too much air conditioning.
Well, it's only Florida. Although, again, as we've been talking about, it's on the cooler side right now of Florida as opposed to later in the launch campaign as we get towards the April dates and even if needed into May and June. Then it goes from the concern of cold weather to hot weather, actually the longer it gets.
Yeah, I was going to say, I think because of ICPS, I'm not going to need any cold weather gear the next time I go down there.
Yes, I won't need to layer 2 different NSF sweatshirts like I did for a rollout. So now, again, we wait to see that crew access arm swing back around into place here. But yeah, there are specific weather criteria for launch, and I think it's worth noting because a lot of the time it's obviously the main ones of don't launch into lightning. Don't launch into upper level winds that are above a certain level. Don't launch into regular winds that are above a certain level. The whole precipitation section on the Artemis press kit for precipitation just says, do not launch through precipitation, period. That's it. But the temperature actually is critical when it comes to fueling up the vehicle and things like that. That has to be taken into account. Obviously, cold brings back memories of a certain other launch with solid rocket boosters. But at the same time, the condition is also that the temperature cannot exceed 94.5 degrees Fahrenheit for 30 consecutive minutes. Any idea why the heat might be more of an issue as opposed to obviously the cold? We can understand O-rings and similar issues.
Yeah, I don't know if I don't think anybody wants to wait around to make that question relevant, but yeah, I'm not sure. I'm not sure what the high temperature, what those constraints are worried about. I know for the cold temperatures, there probably has something to do with the booster. It's possible that it has to do with perhaps there's an upper. I know there's an upper limit on the solid rocket booster. They call it the propellant mean bulk temperature. I don't know that a limit on a particular launch day though would affect it, because it does take a long time to affect the bulk temperature of the propellant. But I know, for instance, for these boosters were actually designed. The design is largely the Constellation Ares 1 first stage design, and one of the things that they upgraded, so to speak, was they upgraded the material in the O-rings to make them more low temperature resistant. And one of the other things that they did is that the shuttle versions of these case-to-case field joints had joint heaters on them, and they deleted those as a part of this upgrade from the 4-segment shuttle redesigned solid rocket motors to the 5-segment. What do they call them now? I don't think they're not reusable. I guess they changed them from, they go back and forth between reusable solid rocket motors to redesigned solid rocket motors, 5-segment redesigned solid rocket motors. But they did remove the joint heaters from the design for these boosters, I believe.
Yeah, I think they kept it as RSRM, but I think it's what you pointed out as opposed to reusable.
Right.
But
So yeah, I think it's called RSRMV, as in the Roman numeral 5.
Yep. They get clever with it because again, Ares 1 and Ares 5 were supposed to be Ares I and Ares V using Roman numerals. So I guess they kind of stuck with that as opposed to Artemis, which is just using regular old numbers. Because it's really just one, it's the Space Launch System. It's not a combination of vehicles, which for those who don't remember, there's going to be the Ares 1, which is, as you pointed out, essentially just for launching Orion, which was still the crew vehicle at the time, atop a single stick 5-segment SRB. There is the Ares 1X test flight, and you could see just how ridiculous that thing looked. And there may or may not have been issues with being able to separate the stages cleanly from that solid rocket booster on Ares 1X. That was part of the problem. But that was the original plan, and then Ares 5, which was going to be the heavy lifter. That was going to be, I guess, most similar to the SLS that we have now, using that orange core stage and being able to do the heavy lifting, bring up landers, bring up payloads. So it could be used, of course, for crew missions to the moon, but it was also meant to be used for payload launches for NASA. This was, again, pre-Falcon Heavy, pre-Starship, pre-New Glenn, pre-all of that. So that was going to be the go-to heavy lifter. Alas, the Constellation program was canceled and reshaped into the current Artemis program that we have today. Wait, were you going to skip? You're not skipping past the terrible separation, are you? Oh, of course, Jay's going to ignore the part of the launch that didn't go well. Right. I see how it is with this Ares 1 hype. There we go. If we're going to be fair, Jay, we got to show it all. So just like Shuttle, it had the point where it would separate away. But yeah, things were a little less than clean on this Ares 1X flight. Apparently, I have to acknowledge that it was at an unfair advantage. What? But yeah, it's also crazy to think that the SRB that you see on the left side of your screen is the same design that is currently being used on the right side of the screen. That boggled my mind when you first mentioned that, Philip.
Yeah, and I mean, I don't know how much of this is the Ares 1X is perspective too. But I mean, the thing is the vehicle has no, when it burned out, it no longer had any attitude control, and I mean what was shaped like a spacecraft in upper stage was of course just, it's a gigantic doorstop. So that wasn't the design of the test. It was just basically the scope of the test was and really I think one of the questions is they then had issues recovering that it was a 4-segment solid rocket motor with a dummy 5th segment, and so but then they had issues recovering that. The recovery system, I think one of the chutes of the 3 tore immediately, and then the other one failed after a period of time, and so then on one chute it hit the water much harder than it was designed to deal with. So that may have been the biggest issue, even if it wasn't necessarily the ugliest, because I don't think we saw that live.
Yeah. So that was interesting to see that spin out there. And apparently we are now in, West Egg? If we're going to Great Gatsby reference, the green light is on. Yes, I went for a literary reference, folks.
We're still waiting.
But the
Looks like
green
we're
light is now on inside the white room there in the crew access arm. So I guess it's a green room at this moment.
I wonder if they're, like, if I recall correctly, for rollout, I guess they didn't make an announcement at first, but then they did eventually say something. So I don't know if we're going to get any advance warning here that it's moving.
Yeah, when we were out there for the initial rollout, there really wasn't much. All of a sudden, it's like, oh, we're expecting it to move, and it's moving. And then, yeah, as you pointed out later, when they were doing the testing of it, they actually made some more announcements. But up to that point, it was kind of just, good luck. We're just going to do it. And again, that's how close they are to home. All I can think of is like Happy Gilmore, go to your home. So close, but we got to, of course, put the crew access arm back into place up against SLS. So that is what we're waiting for at this moment, as the vehicle sits outside the VAB after beginning its journey around 9:45 a.m.-ish Eastern Time. And it is now 7...
Do I see maybe some movement? Maybe? Or am I imagining
Oh, it's
it?
moving. You're absolutely right. There it goes.
Okay.
Now it's very obvious.
Yeah. Well, I was kind of wondering if we'd see some personnel up there, but I mean, obviously that's not a requirement.
Yeah, it's going very slowly at this point, but it is going. This even seems slower than the wet dress rehearsal when they, after completing the first hold as planned in the first terminal countdown test, they then brought it back into place. This still feels slower than that.
Well, it is kind of interesting because I don't believe they have any. This is basically a mobile hydraulic move, if I'm understanding it correctly, because this is a hydraulically actuated swing arm, and so like where they're getting, if this hydraulic power is just coming from the crawler transporter, that's pretty amazing. At the pad, obviously, they have a much beefier, and same thing in the vehicle assembly building. They can't move this arm because they don't have the clearance, but then they can move all of the other arms. They can drive all of the other arms off of, full ground hydraulic supply. And in this case, this is, my understanding would be that this is being driven by hydraulic power. They're getting some of the hydraulics from the crawler transporter here because it's just sitting or standing out there away from the vehicle assembly building.
And you can see there the Artemis logo on the outside of the white room. And Crew 10 astronaut Camille Yui made a joke when it was first out at the pad and teams were out there, basically saying, oh, wow, half of it's exposed. We didn't have that problem, because the crew access arm over at 39A, which he used, which is now removed, and similar to the one over at Space Launch Complex 40 for SpaceX, are both fully enclosed with these gorgeous windows and fancy lighting. It really, it feels like a walkway of the 21st century. So in comparison, yeah, it's a little bit different. And I think that's someone up there, because I see the flashlight moving around there. So I wonder if that is personnel up there doing that. You seen that right up at the top, kind of by that guide wire. There's that light moving around. I think that's internal, not external.
Yeah, we can see somebody.
So there's your answer. If there was personnel up there, seems like yes.
Yeah.
And then working his way around on the fixed service structure here.
Should be getting. I guess this is one where Jerry might have a better view. Except I don't know if he can get all the way to where the crawler is, because it's
not a max view. Because he's on the north side.
Right. So the crew access arm is on the south side.
Yep, there you go. The left view is Max, who is on the north side of the crawlerway. The right side is Jerry, who's on the south side of the crawlerway.
Right. He can't get. He can't. I don't think they let him get inside. So like you can see in the vehicles in this area, sort of where they have a really nice view of it in the launch control center. but I don't think they let them get that close to the vehicle assembly building itself either. But
No,
I guess
they do
now
not.
we'll see what we will see if how long it takes them to then resume and get the they'll go in cross the threshold in the front end, and then they have to get the whole. Actually, the mobile launcher, the deck itself, there's not a lot of room. It takes up the entire base. It just barely. I don't know how much clearance they have with the doors closed. It's probably not that much.
Wouldn't think there's that much. But yeah. So again, that crew access arm getting back into place. It would be nice if they allowed us to use there, but they were kind enough to allow our team to place remotely set cameras inside the vehicle assembly building. So hopefully those cameras are triggering away right now that Jerry and Max placed earlier this morning, and be able to see some cool shots from that when they go pick them up. So if you're not already following us on the socials, I mean, first off, why not? It's awesome. There's great information, articles, updates as we get them of important milestones for all the different missions, but also photos. So to see some of the photos from the roll already, and to be able to see the photos that were taken from inside the VAB, go ahead and check them out on X, Facebook, Instagram, Threads, TikTok, Blue Sky. Post on those and see all of the cool action happening, both at KSC, Starbase, and other parts of the country. McGregor. No.
You mean besides chat?
Yeah, apparently a frozen stream.
Oh dear.
Which it's hard to get confirmation from people because they can't use English words. Also, apparently we've got something cool that should be going in front of the VAB shortly. But we'll see what we get. There we go. I think chat's back. Sweet. Hello, chat. 5x5s. You can hear us. If you have the emoji, that should work. I think 5x5 does work if you're able to type that. I think that will work. All right, I'm seeing it. There we go. Well, you didn't miss much at this point. Rocket's still there. Still hasn't moved at this moment. As they secure the crew access arm into place up against Orion up there at the top of the Space Launch System SLS rocket that will eventually, at some point, launch the Artemis II mission. As of right now, very likely no earlier than April. Also worth noting that the original plan for Artemis was to launch no later than April as well, of which there is the 1st, 3rd, 4th, 5th, 6th, and 30th currently available in the month of April for them to launch. And I'm seeing in multiple different languages that people are able to hear us. I'm seeing French, seeing German, I'm seeing Klingon. Thank you, Chris. But yeah, we remain at that 99% on our little loading bar there on the ticker. And it's nice actually seeing chat somewhat active, again, even if it is totally different languages. And again, for the people that speak in French, I appreciate it because I actually do speak French, or at least understand it to an extent, so that is somewhat helpful. As I try and translate some of the other ones, like one that's in German that was asked earlier. Let's see. Here's one that I think I'm translating, saying, has NASA communicated any concrete restrictions that prevent the announcement of the launch windows in May? Could it be due to the weather in Florida? I wonder if it was just because of the fact they're a bit stubborn on the we really want this thing to launch in that no later than April that we've been promising. Is that kind of maybe why they haven't really put out any May windows yet? Because there are May launch windows set aside. They just really haven't put them out there.
Right. I mean, again, maybe I should go check the Artemis II availability page, but the April 30th launch opportunity is a part of launch period 20. And so the ones at the beginning of April are a part of launch period 19. And that's just the numbers just have to do with they started doing detailed analysis of Artemis launch opportunities that long ago. So back kind of in the late 2024, early 2025, they started looking at those opportunities and doing mission planning analysis of that long ago. But there seems to be more reluctance to share preliminary information. So they were asked why they could not provide launch period 20 information, and this was actually in that short period of time after the second wet dress rehearsal last Thursday, but before we found out about the issue with the ICPS. And so I think some of the media that were there wanted to have a better understanding of what opportunities exist past the end of April. And of course, Artemis II has had many launch dates. The no later than April is really technically a congressional commitment date, and so they will have some period of time if they miss April and go into May. They have a little bit of margin, I suppose, before they would need to basically redo the official launch date. And so you don't typically see no later than used for these, but it has to do with, I believe, the fact that this for Orion is when they will complete their a specific part of the program life cycle. And so SLS, they completed that part of their life cycle with the Artemis I launch, and they're finally able to you don't see the cost and schedule overruns calculated for SLS anymore. Or at least not till we get to Block 1B. But until Artemis II flies, you will see those same constraints and same numbers calculated, and for Orion until after they complete this mission. I heard that.
All right. Yep, that's why I was quiet there for
7:35.
For to be on stations for a comms check for all the crew that will be working inside High Bay 3. Again, that is the high bay that you see on your screen with the doors wide open, ready for SLS to roll inside so that they can go ahead and continue working on hopefully fixing that problem that they encountered with the ICPS, the interim cryogenic propulsion stage or system. Is it system or stage? I always get them confused. It's stage, right?
I think it's stage. So yeah, interim cryogenic propulsion stage, and it's completely. It's very similar to it's almost exactly the same as the Delta cryogenic second stage. It has a slightly longer liquid hydrogen tank. I think it has some addition. It has like an additional. They use hydrazine for attitude control. It has, I think, an additional hydrazine bottle. But it's very much, it's very similar to. It's just a different application, and so, Delta used it like a regular upper stage, where the first stage burns out, and then the second stage completes ascent and insertion into low Earth orbit, into a parking orbit. Whereas for this vehicle, there is no circular parking orbit. The core stage leaves everything in an egg-shaped orbit with a really high apogee and a really low perigee, and then the ICPS does the shuttle version of OMS 2 when it gets around 45 minutes after liftoff. So it's same stage, different application.
Yeah, and it's worth noting, it's as it says in the name itself, this is an interim stage. Of course, once they if they, I should say, but the plan is once they get to Block 1B and Block 2 of SLS, that's when they will switch to the EUS, which is the Exploration Upper Stage. So just a little bit of a difference there. So this is kind of temporary for Artemis, I believe Artemis 2 and 3.
This is a long time to go with. I mean, as you're saying, so this vehicle that's going to fly the first 3 missions is using Ares 1 boosters and Delta Upper Stage. So the only new thing, and space shuttle main engines. So
yeah.
But then of course the thing that took the longest to do was the new build, which was the core stage, and so. Yeah, these are the upper stage and the boosters were not designed to fly with this vehicle, and it just means that it's not really optimized for the rest of the for applications. So one of the reasons that you have this sort of repeating pattern of which we saw more clearly during Artemis 1, where you have 2 weeks of launch opportunities followed by 2 weeks of no launch opportunities, is because you have to launch into this non-circular parking orbit. And so one of the advantages of the Block 1B flight profile is you go back to that circular 185 kilometer parking orbit, and purely from that standpoint you would have the opportunities to launch pretty much every day.
Yeah. And it's worth noting as well, you've probably seen on your screen the lights kicked on, and so have the motors. The crawlerway is not moving. The crawler is once again moving along that crawlerway. This will hopefully be the final stop of this trip, and it will hopefully continue all the way into the vehicle assembly building from this point. Of course, they may slow down at spots, especially with this final kind of push here to get into position, make sure they're lined up with everything so that they end up inside High Bay 3, exactly where they want to be, so that they can then move all those work platforms back into place. While we have that moment, then, let me thank some people. Again, some of these things are getting through, some of them are not, so we appreciate everyone bearing with us through all of this. It's a YouTube issue. Alaj, thank you for becoming a PadRat member. Glenn Taylor, thank you for gifting a Red Team membership. Jim Graves, thank you for becoming a Red Team member. And Lil Sahiro, I believe, thank you for becoming a PadRat member. Appreciate that all very much. I also loved how you could see when they were first getting the engine restarted up, that giant puff of that old kind of like smoke exhaust coming out the back, because there are some giant motors that need to make this crawlerway move. Or I keep saying crawlerway. To make this crawler move.
Yeah, I believe those are diesel engines, and so I'm glad I'm glad I'm not right up next to them. But yeah, these are definitely old school engines to drive this. And we were listening to that announcement about the 735. That might coincide with they're going to need a bunch of spotters around the edges. You're going to want people to be making sure that all the clearances are clear as the deck and then the umbilical tower come in and it cross the threshold into High Bay 3, and then eventually once they're lined up, the crawler needs to lower the mobile launcher down onto the pedestals inside the high bay, and then there may be a few other cleanup tasks that they need to do before they can start getting into extending the platforms and getting into that work. And it sounds like they are not going to be wasting a lot of time. And so, but I mean, we're definitely still going to be wondering how long is it going to, how long are they going to be inside, and when they're going to come back, and then how much time it's going to take them when they get back out to the pad.
Exactly. Because, again, we just know that there was an issue with helium aboard the ICPS upper stage there, and Jared Isaacman in his post announcing the issues with it, and the likely, which obviously now become the eventual rollback, was that there were 3 different potential issues that it could have been, and they're going to have to figure out which one of those it is. And the issue was, though, each one of those fixes required access to that ICPS, which could be easiest and pretty much only obtained through the work platforms inside the vehicle assembly building. And he did point out that one of them was very similar to something that was seen on Artemis 1, but that they had made improvements to it. So what was the issue, Philip, if you remember, with the ICPS and helium on Artemis 1 that might or might not be related to the issue that we've seen now on Artemis 2?
Well, I think that may have been somewhat of a process issue, and maybe somewhat of if I recall correctly, this was the very first time they rolled out to the pad with a full vehicle with the Artemis 1 vehicle. So this is March and April of 2022, and they were trying to do the wet dress rehearsal for that vehicle, and they had initial issues with just, they had some issues with configuring the pad correctly, and they had some initial issues with loading. They learned some lessons with liquid oxygen loading early on, and in one of those scrub turnarounds, they had an issue with the pneumatic system, and a gasket in the system got blown into, I think, through the umbilical, or maybe it was from the umbilical into the ICPS plumbing itself, and part of that had gotten lodged on a check valve, so it was the opposite of what they were seeing, I think, or what they reported seeing on Friday night into Saturday, which was no flow, which is where the opposite of what they saw. But it could work both ways. But what they saw back then, if I recall correctly, was with if the check valve was completely closed, you should see no flow from one side to the other. And in that case, they were still seeing flow. So that, I think, was there's probably some process involved, but then they may have also talked about, if I recall correctly, they were talking about, I think the phrase was something like a purge boot for the umbilical arm, and so they may have made some improvements there. But I think the long and short of the issue in general is that they do not have the ability to access they don't have a lot of access to the vehicle to do servicing and maintenance while it's at the pad. And so there's a similar thing where they then subsequently also had an issue with hydrogen leaks back then on Artemis 1. But again, somewhat ironically, or maybe not, they actually have the ability to deal with the hydrogen leaks in the tail service mast umbilical while they're at the pad. It was the issue with the ICPS back in, one of the issues. They also had that nitrogen Space Center supply issue, and thankfully that seems to have been sort of resolved on a long-term basis since then. But one of the reasons, there were two reasons that they rolled back then. One of them was because it was going to be weeks before they could fix the nitrogen supply issue, but then the other was because they could not fix the problem and get their hands on the check valve and the plumbing in the ICPS. They had to roll back to the VAB to do that.
Yeah, so it's a little disheartening to see similar issues popping up again. First, the one that we saw with the hydrogen, but again, they fixed it better than the levels that we saw during the first Artemis mission, and now to have something similar with this, where there's a clog or a block or some issue where you just can't get helium inside that upper stage. So it's a bit frustrating. But again, it's one of those things that while the vehicle is still on the ground, especially given that this is a crew mission, you want to make sure that the vehicle is safe and it is ready to go, because the last thing that NASA needs is to, have issues during a flight with people on it. Which is funny, because you compare that to something like SpaceX, where, obviously people say, oh, there's only been, one Artemis launch so far in all this time. This will be the second. They can't even get that off the ground. But it's worth noting that Artemis 1 was extremely successful. And with all of this, I'm hoping that we will see another extremely successful mission here with Artemis 2. Compare that to something like Starship, where 7 had issues, 8 had issues. Basically Block 2 was kind of just, we're going to blow up and have things not work for most of the program. It's amazing the difference between the two. And I mean, I kind of wonder why they test so differently. And I'm sure you've probably wondered too. Well, if you want the answer to that, we will have it for you in less than 30 minutes. We have a brand new video premiering here on the NSF YouTube channel talking all about the ways to get to the moon, of iterative design versus all of the ground testing and everything ahead of time. So if you wonder why is it that SpaceX is totally cool blowing all this stuff up and doing this type of testing, whereas something like SLS or even New Glenn, they are a lot longer to get into action, but we saw a successful Artemis 1 flight, we saw a successful New Glenn Flight 1 quote-unquote payload delivery, and then a totally successful Flight 2, including the booster catch. It's a really cool concept and a real interesting video of why. So you'll be able to check that out less than 30 minutes from now, and we'll redirect you right over there once we do. So get ready for the excitement on that. Meanwhile, the excitement is slightly on hold with this because it looks like the crawler transporter has indeed come to a stop at the moment. Don't know exactly why or what they're working on there, but the vehicle, it appears the crawler has stopped moving up to this point. Maybe it could be just getting those final adjustments and everything ready before that last push inside the high bay. I don't know if they're waiting for something to be finished being prepared and ready inside the VAB. You can see the people walking around the outside of the crawler right now, kind of in between those two tank treads on the left side. There were some people walking around. But it looks like just one final checks and things before they end up inside the VAB. And did I say booster catch for New Glenn? I meant booster landing, sorry. But I'm not sure why they would kind of pause at this point here.
Well, I know that they do like to put I think they put plywood down on the floor of on the floor as the crawler goes over it. But I mean, you would think that I wouldn't imagine that they would have stopped for that they would have had that ready, assuming that they did have it ready. But they may also have, again, they are going to go a lot slower as they cross the threshold, because the clearances become very tight. But it doesn't look like it's moving at all right now, and so that's really slow.
Yeah, 0 miles per hour is definitely on the slower side, I think.
Yeah.
I'm seeing some more people actually being able to kind of speak and chat. It's actually impressive right now. I mean, there's obviously some quirks to it, but actual phrases are getting through.
Yeah, in English.
That too, without asterisks and umlauts and accent aigu and all that stuff. Yeah. There we go. And I see, there we go. Kind of Nightbot also semi-working at least now.
We're going to need an English command in chat at some point.
Oh, we have one. It's just we haven't really needed to use it because that's been the only way to work around. For some reason, the Blame link didn't work, which, again, Blame Helium for a very limited time is available in the shop. If you're saying, oh man, I wish I'd gotten the Blame Hydrogen one, and then it disappeared because it was limited edition, well, now there's Blame Helium, given the whole issue that we had with the ICPS on this one. The whole reason they're just about back inside the vehicle assembly building. So you can kind of get the Blame Hydrogen shirt. It's just a little tweak with a little another and the E added on, crossed off to add the helium to it. So that is available for a very limited time right now in the shop at shop.nasaspaceflight.com. And if you're a part of that team who's going, well, all the other ones are using, methane. Again, like we were talking about, the iterative development video coming up in just a couple minutes, talking about, well, New Glenn and Starship, they all use methane. So that's got to be some kind of improvement or better. If you're on that team, well, you can give your thumbs up and your vote that you voted for methane by getting the shirts or the sweatshirt or getting the I voted for methane side of this limited edition merch over at shop.nasaspaceflight.com. So check it out while you can. How many different blame commands are there now? Blame 2, blame 3. It's one of the blame commands there. You could see Chris Bergen putting that out in chat. There you go. This is a look inside the vehicle assembly building now, as the big orange rocket gets ready to roll inside. That is such a cool view. The vehicle assembly building is kind of mind-boggling, because, yeah, there's multiple different levels and things, but it's technically a single story, and it is the largest single-story building in the world by volume. So it is massive, it is spacious, the echo is unbelievable, and when you first get in there, depending on the weather, there is a wind tunnel effect. When you get in, that will blow your hair back. I almost said your socks off, but more your hair back. This thing is massive. It is an engineering marvel all its own to have something this large, be able to stay up in Florida with all the hurricanes and everything, protect the vehicles and the people working inside, and oh yeah, being able to assemble moon rockets since the 1960s and now continuing into the 2020s with shuttle in between.
I thought I heard some crawler sounds. I wonder if they're getting ready to roll again, or
think so. And yes, I see chat working. Of course, it's already just about to enter the VAB, and now chat is working. With a little refresh, of course. And it sounds like the call out there was go for on station in 2 minutes. So that's what they said, was about 7:35. And
okay, so maybe it's possible they just got ahead of the spotters.
NASA being ahead of schedule? Sorry, I had to say it. The intrusive thought one. But yeah, so once they are on station, again, they'll do the final roll inside the VAB, where they will then hopefully get it into place. And do they technically call it a hard down as well? Like, because at the pad they call it a hard down once it's lowered down into place and placed on top of the structures to then mount it to the ground. Is that the same terminology in the VAB?
I think they'll still call it, getting hard down on the pedestals. Because then I think, similar to, doing the opposite when you're picking up to go from one place to another, you have to disconnect the shore power essentially, or the pad power from the mobile launcher, and they will get down on the pedestals first, and then they will do a power transfer. I don't know whether they need to do that in parallel with, once they get on the pedestals and transfer the load, then they can probably start working on platforms and things like that. But they will also have to do a power transfer from the crawler to the VAB.
Yeah, because, it's worth noting the crawler doesn't really have much interaction with the vehicles itself, because that's the whole point of the crawler, is that it's meant to be vehicle androgynous that can work with any vehicle that might need its services. Although, right now, the only one actually using them is SLS and this. So, there's kind of that caveat to it. But it has some integration with it, but its main goal is literally just like for those who remember the commercial in the United States, I lift things up and put them down. It's kind of like that. So now
it looks like it's still looks like it's motionless, so to speak. But I guess they did say 7:35, so we're just coming up to that now.
That's exactly what I was about to say, is they're just getting on station now. So we'll see if they do that final push inside the VAB. Again, this roll started about 10 hours ago, I believe, if my math is right. It was at 9:45-ish. So coming up on approximately that 10-hour mark of the roll from at LC-39B, along the crawlerway, past 39A, past the press site, and now almost inside the vehicle assembly building, High Bay 3. This is so cool. So now we'll see how much longer it takes them to do these final bits of travel to get it into the VAB, set down, and then get those work platforms back in place, and then actually be able to get the platforms around it, and finally, after all of that, get to the access they need for that ICPS stage to be able to, well, it's like saying ATM machine, to the ICPS to go ahead and figure out what the issue was with the helium system that forced this rollback on that ICPS. And also, as we were talking about earlier, Philip, they're not just going to be accessing the ICPS. They're also going to be working over at the boosters with that flight termination system area as well, right?
That's right. That's what they said. The two other things that they talked about, I believe it was in yesterday's blog update, were they're also going to replace some batteries, some flight batteries in the ICPS in somewhat of the same location inside the launch vehicle stage adapter. But then they are also opting to do the refresh and reset of the flight termination system inside in the VAB rather than do it back out at the pad, which were they're getting set up to do when they found out about this ICPS issue in the first place. So we'll just, and again, I think we will just have to see if there is anything else that they're going to add to that work list while they're there. But of course, you run the risk when you do that of taking on more work, that it's going to take longer, and it's going to be. It seems like it's going to be pretty tight for early April, because if they're going to need 2 weeks when they get back out to the pad, or something around 2 weeks, then as we were talking about earlier, we're 5 weeks essentially from April 1st. Today, and so that gives them 3 weeks. Sounds like a lot of time, but it can go by pretty quickly when you have, with all of the setup, and then setup before you do these tests, and then clean up and getting the vehicle then ready to roll back out afterwards. So I think I'm hoping we'll get maybe a little bit more detail on what else they're going to do, and then obviously the bigger question is how long they expect this work to take, because any extra time that they can give themselves back out at the pad is going to give them additional contingency time and margin to deal with either weather or other issues that they might have when they get back out to the pad. Because right now, it seems like it's pretty tight for early April.
Yeah, I mean, my guess is there's probably other things they saw out at the pad that they want to at least look at or check or confirm during those 2 wet dress rehearsals, I would imagine. So it's a chance for them to just double, triple check things, maybe see how that seal work held up back inside the VAB under the lights and controlled conditions. Don't know. We do know they're going to be working on the ICPS issue. We do know that they're going to deal with that flight termination system refresh, which looked like they were about to do out at the pad. They even had the work platform out against the vehicle for it, one of the changes that they had made since the Artemis I launch, where that was an issue. But alas, here we are rolling back inside the vehicle assembly building. So we'll have to see what ends up happening, how long they take, because it is already only 3 days left in February, with it being a short month, and then we'll see how much they're able to do. They will then have to roll it back out, reattach it back to the pad, set it down, reattach all of the ground systems, the ground plumbing, the slide wire baskets for the escape system. All of that will have to be brought out, retested, rechecked, and then after all of that, I'm going to imagine that they will want to do testing on that ICPS fix out at the pad to see if they can actually pass the helium through the vehicle. We'll see if they end up having to recheck the tail service mast umbilical to see if the helium or the hydrogen leak is still an issue there. All of that still has to be done, with the next launch window opening up April 1st and closing April 6th. The more I say it out loud, the more concerned I am.
Well, I think it was as you were running through that, one of the other things, there's a couple things that they may not. Well, one thing I know that they don't have to do is they won't necessarily have to reservice the solid rocket booster hydrazine tanks. So those are loaded for launch. they opted to leave. I believe they opted to leave just because it didn't seem like there would have been enough time between, having this rollback bomb go off on Saturday and then being ready to roll yesterday and then having to wait for weather. But that one they shouldn't have to do, which will save them some time. And then they did some RF testing, program specific engineering tests. They call them PSETs. When they went out the first time, and maybe they don't need to do that when they go out again. But I'm not sure that's. I would imagine that will save them maybe a handful of days, but not a lot. And so we don't have enough information to tell how tight. And so maybe they'll come back and say, well, we have. Once they tell us how long they're planning to be in the VAB, I think we'll have a better idea about how tight it's going to be to get to whether they can get to early April or not.
Exactly. And we'll have to just keep an eye on it. And again, that's part of the difference of, being extra careful and things before the launch versus iterative design and basically test as you go, which we have a video coming up about that in 10 minutes. So just a reminder, stick around here at NSF. We'll have that. And then, of course, following that premiere, we'll, of course, be continuing showing video, as long as we have it, of SLS rolling into the VAB over on Space Coast Live, our 24/7 cameras. Let me just take a moment here and thank someone really quick. OrtCloud with the tip at tips.nasaspaceflight.com. Chat using hiragana and katakana is directly supporting my mission to learn the Japanese language. Thanks, y'all. Anyways, since it's taller by quite a bit, will NASA need to modify the mobile launcher for Block 1B? No, they won't modify it. They're just going to build a new one. In fact, they have a new one under construction, Philip, just next to where the rocket is right now, I believe.
Yeah, I think it's been in the background for a few hours here as Mobile Launcher 1. There we go. So yeah, there you go. So it's they've pretty much installed all of the umbilicals and accessories on it, and now they're basically doing all the internal outfitting. So all of the systems, again, from hydraulics, pneumatics, electrical, communications, data, and then all of the internal plumbing for things like water and liquid hydrogen, liquid oxygen, helium, nitrogen, all of that fun stuff has to all be connected up. And they're hoping, I think, again, they're the optimistic schedule. I think they have some incentives to try and finish this and hand it over to Exploration Ground Systems by the end of this year. It might be a little bit more. It's probably more realistic for that to happen next year in 2027. But hopefully we will get a little bit of an update sometime this year. It has the updates got a little quiet after the White House proposed terminating all of that last year. So they've been shy since then. I guess I can understand why, but I'm hoping we will get some updates this year finally.
That would be very nice to actually get some updates on that and see progress on it, because that has been so far behind, and finally getting into construction phases. I believe Bechtel is the one working on that. So, yeah. Hopefully we get more info on that soon. Apparently we have a new video from the field. So, talking about boots on the ground, there are the boots, or at least the shoes. And then looking up, look at that. Such a cool angle to see SLS from next to the VAB. A huge, huge shout out to NASA Public Affairs for this opportunity. I mean, we've of course been on the south side for most of the rolls and for most of the activities here. This is such a unique vantage point. So cool, Max. I'm so glad you're able to get out there and that we were given that opportunity. And clean your shoes, sir. But look at that. Oh, that is gorgeous. Hey, chat, is that not a cool view? That is so cool. Oh, we're so glad that this is an option. Oh, that's awesome.
Well, and so that is one advantage to having it stop right outside the VAB, is you get Max and folks like him get an extended look at the vehicle here. It's basically just sitting outside the VAB posing for a little while longer.
And speaking of, the posing is done. It is moving once again, just as you said it. So, we got to get you to speak things into existence more, Philip. Like maybe actually getting it to launch during a daylight window.
I guess I didn't speak March 3rd out loud, but that if I did, that obviously didn't work. My powers of making future events happen are pretty weak. I would not. I think I would have opted for the first wet dress rehearsal not to have a hydrogen leak, since I was basically there ready to cover the launch and wasn't thrilled with having to come home and have all of my interviews canceled. So, I'm having trouble believing in some of the superstition stuff.
Okay, fair enough. Fair enough on that one. But yeah, if you want to do some superstition, voodoo, future predicting stuff, not against it.
We gotta find somebody who believes in that.
Yes, chat, do you believe in miracles or something? I don't know. We need your help making all of that happen. Oh man, that is such a cool view. Again, you see that the progress bar at the bottom of the screen now is like the progress bar on the right side of the screen of that final little percentage push inside High Bay 3 of the VAB. Oh, that's awesome. And again, you can see there the crew access arm back up against Orion. We saw them swing that back into place just a short time ago. And now on its way in. Again, this journey began pretty much exactly 10 hours ago at this point from 39B. It was daylight then. Remember that? So, yeah. Again, this vehicle can go up to about like a mile and a half an hour. But at this point, for the slower portion, it's closer to about 0.8 of a mile an hour, I believe, for the speed. If I remember reading that rightly in the documentation that NASA put out. So, hyperspeed. Which, it's funny that this is considered fast for crawler speeds. Oh, this is on the slower crawler speed, but still. Oh, these views are amazing. And our team has been getting some other amazing views out there that are also now available as prints in shop.nasaspaceflight.com. Jay, I believe we have some brand new ones in the shop, including this one, Big Orange in all her glory, taken out there. I believe this is Max's photo from out in the field. Oh, that is so cool. The lighting, the sunset lighting for this was absolutely spectacular. Look at that. Oh. And you can really see all the detail in the boosters and everything. That lighting is awesome. And then, but wait, there's more. There's another one. Again, given this amazing, unique view that we were given from NASA. Take a look at that. Going to its home. Get in your home. High Bay 3 loading, the title on this one. Great names. And there it goes. These are all available now. Shop.nasaspaceflight.com, as well as our very limited edition Blame Helium merch. So if you want to get it, it's getting close to time for the Helium merch, but these prints will be available along with all of our other Artemis merch in the Artemis shop page on shop.nasaspaceflight.com. But yes, you can blame hydrogen and vote for methane instead with this limited edition merch, which, a reminder that methane, something used by Starship, something used by New Glenn, both of which use very different techniques to get out onto the launch pad and launching, whereas SpaceX is more, let's launch it, and if it blows up, we learn from it, whereas something like New Glenn, both of which use methane, is more of a, let's take it slow and steady and learn from it. Is one of the better? Is there really a difference to it? How is that kind of comparison? Well, we'll take a look at comparing all of those different ways in the new video premiering just a couple of minutes from now here on this very YouTube channel, talking about the whole iterative development process and why Starship iterates and SLS doesn't. Two different ways to get to the moon. So as we do that, we are going to be wrapping up our dedicated coverage here and we'll take you over to that video. And don't forget, we have 24/7 live views of everything going on at the Space Coast, including while this roll is continuing over on our Space Coast Live 24/7 feeds. Really quickly, let me thank some people here in the support queue, and then thank everyone that was with me. We had Devin gifting 20 Red Team memberships. Thank you so much for doing that. If you got one of those gifted memberships, definitely make sure to give them a thank you. Now the chat is working. And for this portion of the rollback stream, I have to give a thank you to Philip Sloss for the amazing commentary with me. Thank you, Philip.
Thanks for having me. I'm available for helium balloon parties and other shuttle rollouts or SLS rollouts in the future.
Instead of weddings, birthdays, bar mitzvahs, it's rollouts and rollbacks.
Yeah.
I love it.
I haven't seen a lot of helium. I guess they do helium balloons at weddings, but yeah, you don't see a lot of those there.
And then producing this portion of the stream here is Jay Keegan. Thank you very much for doing that, Jay. And then a reminder earlier, we also had Carson, Ryan, and Ryan for the first part of the rollback stream. But most importantly, I need to thank Max Evans and Jerry Pike, who are both out in the field bringing all of these views to everybody. Really appreciate all of that. You can see some of their names and info cards flicking up in the corner of the screen, both British Ryan and American Ryan up there as well. So a reminder, again, iterative development, why Starship tests very differently from NASA and from Blue Origin, all of that coming up just a couple of minutes. We'll redirect you right over there and then send you from there back over to these final inches of SLS as it goes away from our camera views and inside the VAB. I'm Sawyer Rosenstein. I have been your host for the second half of this SLS rollback stream. Thank you so much, everybody, for watching. Now let's go check out the new video.
And here we go.
There's the W. Here's ignition.
Doubling up.
Did it just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, Jingle.
Back at home, we all have a lot of work to do, but from here, that sure looks like a perfect flow.
Propulsion continues to be nominal.
We did have an observation. 343 unfolds to go.
It's orange!
Water towers can fly!
Bingo! Right in the center.
Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my God.
Yikes, you bet. We don't need any more of these.